So last time we got, in this course at least, our first taste of object-oriented programming. Okay? And we knew it was object-oriented programming because we did not use the word static anymore. And we saw last time that if classes are factories and objects are products of those factories, then static methods essentially go and deal with the factory. Okay? So there's no notion, and non-static methods, which we call instance methods, deal with instances produced by the factory. So if you're only dealing with the factory and not dealing with instances, then that's not really a factory. It's as if for every card that you're going to have a separate assembly unit, and there's no reuse. There's not as much reuse. So we took an example of a square calculator, and we saw that a square calculator was a class, and in it was a function that just squared, and that function was wasn't really an operation on an instance of a square calculator. Okay? So you would first instantiate the square calculator. You'd first buy a card from the factory, and then you would run. This is more indirect. You just don't go to a class and start executing static methods on it. Okay, these are the factory methods. You first go name the class, then you go instantiate it, and then you get an instance and invoke an instance method on it. Okay, so that was one example, and here's another example. It's a BMI calculator. Again, this is a class with only one operation, one function. In general, a class could have many functions. And where a square calculator took only one parameter, this calculate square took, or I think we call it square, took only one parameter. This calculate BMI function takes two parameters, the weight and height, and it computes the BMI out of these two values. Okay. And for this formula to work right for BMI, your weight should be in what unit? Kilograms. And your height? Meters. Okay. If you want pounds and feet, you have to convert these into convert those values into meters and kg. Okay. But that's not important. What's important is what a class looks like, and here's something with two parameters. Okay. And we saw last time that we could go and either write a main that instantiates the class that we've defined and invokes methods on instances of that class on an instance, or we could use object editor. Okay. And here I'm writing my own main. Okay, so writing your own main was like driving your own car, and using object editor was like having a chauffeur. Okay, where you indicate what you want, you don't indicate the details of how you want it, and the how is figured out by object editor. Okay? And you can imagine an object editor for C#, C++, other languages, and the user interface would remain the same, but underlying what you do would change, okay, depending on the language. Yes. Okay. Now, this main is a little different from the main we wrote last time. And anybody see something they haven't seen before or is confusing in this main? Sorry? There's an instantiation, but we did an instantiation last time too. You don't remember the code, but nobody sees anything confusing here? Yeah.
Because there's not a value for weight and height.
So we go and say, here I instantiate a BMI calculator, and then what am I doing? So what exactly am I doing? What is the first line saying? Sorry? Create an instance of class. That's what the right-hand part, the new BMI calculator says that. What is the stuff before the equals?
Name a variable.
You've got a variable called BMI calculator. Okay, so, and then its type is? The class. Last time we had one expression where we said new square calculator, and then we took that expression and invoked on it the method. We never stored the value in anything. Okay, here we're taking an object, an instance, and storing it in a variable. Now you've seen before the idea of storing a program value in a variable. Okay, we see this here. Double weight, that's a variable. And what value does that store? A double. And how do you assign to this variable a value? You instantiate classes. Sorry? You initialize it, and in this slide, is there anywhere where this variable is being assigned? Right here? I'm essentially assigning this parameter to this parameter. We call this a parameter also, we call this a parameter also. Are there two different names for these parameters? It's a little confusing, right? One is a variable declaration, one is an expression, a value. Have you guys heard in your previous classes terms for these two kinds of parameters? Yeah.
Well, I thought that those were parameters and these were arguments.
Oh, so this is an argument and that's a parameter. Is that what everybody, is that the convention nowadays?
I think that's called actual parameter.
That's an actual parameter and that's a
Reference?
reference or something else? A formal parameter. Okay? So a formal parameter is a variable. Like any variable, it has a type. Like any variable, can be assigned a value. You don't say that variable equals something. You just call the method with what you're calling arguments. Okay, but I don't know what the nomenclature keeps changing all the time. But argument and parameter are synonymous. Okay, typically synonymous. Maybe they've changed the nomenclature. And you pass to it an actual parameter, and 75 gets assigned to weight, and 1.77 gets assigned to height. Okay, and it's positional correspondence. Okay, that means the first actual parameter gets assigned to the first formal parameter, and so forth. Okay, you have to have as many actual parameters as there are formal parameters, unless you have arrays, which gets confusing a little bit. Okay, so so we've seen variables before, and we've seen variables right here, and this is also a variable. The type of this variable is a double, which is provided by Java. Okay, so you say, okay, Java provides us with a bunch of types, and we can use those types in variable declarations. The type of this BMI calculator is, and this is a type defined by whom? By us. Power. We can define our own types. Okay, these are called programmer defined types. Okay, so every class is also a type. A class can be instantiated to create an object, and a class can also be used as a type of a variable that will hold an instance of that class. That's what's happening here. I'm saying a BMI calculator, the type, then the variable, and then I'm assigning to it a BMI calculator instance. And by associating this variable with the type, we make sure that I don't assign to this a square calculator. Okay, so that's what typing is all about, to make sure you don't do bad things. Okay, some languages don't have type declarations. Okay, Python is one of them, and then you get into trouble when you are executing the program if you did something wrong. Okay, so that's the only difference from what we saw earlier. Yeah, Mark.
So then BMI calculator type is not necessarily an integer or a string or a double.
It's
Just an object.
It's an object type.
An object.
Right. It's not a predefined type. It's a programmer-defined type, and that programmer-defined type happens to be a class, which is a type of object. Okay. Your double and int are not object types. They're called primitive types. Okay, and they're also predefined types. Okay. So let's see. Formal parameters, just as we mentioned, actual parameters, and at method invocation time, the actual parameters get assigned to formal parameters. And this is an instance method, no static. And this is the type, okay, just as I said. And a variable that holds instances of a BMI calculator. Okay, any questions? And we saw last time actually this thing. We used the word formal parameters and natural parameters last time, and we showed that we can assign these values through main or through object editor. And this is interactive assignment, and the other one is what we saw in the previous slide was procedural programmatic assignment. Okay, and as this picture shows you that weight and height are variables, and they can assign these values when you call them. Now, what's the lifetime of these variables? When do these variables get created? These two variables. When the object, when a BMI calculator class is instantiated, those two variables get created? No? Marco, no, why not no? Why no?
Well, they get instantiated and called when the...
No, okay. When do they get created? Instantiated called...
That get created?
Sorry? Yeah, when did weight and height, the variables, get created?
When you're parsing the argument to...
When you're passing the arguments, or when you are? When you call the method. When you call the method, at that time they get created. And they disappear when? When the method ends. Okay? So we're not going to talk about different kinds of variables that have a different lifetime. But this is the lifetime of these variables. Okay?
So it's different from when you instantiate the
so when a BMI calculator gets instantiated, I have no variables here that get created at that time.
So you have to call.
For these two variables to get created, this method has to be called. Okay? That's why they are formal parameters. Formal parameters always belong to a particular method. They're declared within a method, and they get created when that method is called, and they disappear when the method call finishes. Okay? And each time you call the method, new formal parameters are created, and they get assigned new actual parameters. Okay. Now we saw that object editor provided with the user interface to allow you to dynamically call a method multiple times without rerunning the program again and again. Okay? So I could go and call calculate BMI with 77 1.77 and get some value, and I say, I don't like that BMI. I can't, you guys are probably still changing your height, but I can't. So the only thing I might have some control over is my weight. So I go and try a different weight, and maybe I like this BMI value. Okay? So I can do these what-if calculations. Now, I told you that object editor is great for the following reason, that I don't have to go and write, I can go and call the method multiple times without binding the program to a certain set of action parameters. But I'm still duplicating some effort, right? I entered the height once here, and let's assume that object editor does not remember values, because we don't know how to remember values right now. Okay? Then the next time I'll call the method again. I would have to go and fill in fresh values, but I'm not really changing the height. All I'm doing is changing the weight. Yeah, question? You're just wondering where what goes? So, last time we discussed this in great depth, so you'll have to go and look at that again. And I'm just taking a snapshot from it. And what you did was you instantiated the object, you said object editor.edit object, and it gave you a object editor window, and from there you went and invoked a method, and you got this. Okay? So once you guys get some more practice with object editor, you'll remember that more. But so that's what you invoke the method once, you got this value, you invoke the method a second time, and you went and filled these values. So I don't want to put this value again and again. Okay? And I being the user. And we can actually, play around with object editor and make it remember values, and in fact it does. Assume it didn't. Okay? And that's what the initial version of object editor I created didn't remember. So as a user, I don't want to enter the value again. Object editor is not cooperating. As a programmer, can I do something? Yeah.
Make a global variable.
Make a global variable. Okay? Before we go to that, let me try. So I'm re-entering height each time. And here's what I could do before I go to global variables, because I don't know what global variables are at this point. I go and say, okay, I'm going to write a program for myself. So I'm going to write a calculate my BMI. So I'm not learning any new primitives. I'm not changing object editor. All I'm doing is changing the program. And I say calculate my BMI. It takes only one parameter, weight. Height is needed for calculate BMI. That height value is in this funny kind of variable. So it's not a variable. It's a constant. But isn't this a constant also? Is this a constant, or is this a constant, or they're both constants? So what's the distinction between this constant and this constant? Anybody heard terms for these? They're both constants, just as parameters used for both formal parameter and actual parameter. The word constant is used for. You must have heard these terms. You just don't remember them. No? Literal? Anybody heard the word literal? Yeah. Nobody? What would the word literal mean? Yes?
It's a literal. I don't know why it's a literal, but it is. It's written out.
It's literally written out.
Okay. Yeah.
Okay? And if this is a literal, this is a constant, what kind of constant is this? A named constant. Okay? So this is a named constant. A named constant is like a variable. Variable has a name. Constant has a name. It's a name we gave, so we created it. Okay? And how do we know this is a named constant and not a classic variable?
Usually in Java, you use small caps.
So by convention, all caps means a named constant. So you would imagine a programming language that looked at the case, and depending on if it was all caps, it would make that a named constant. That would be actually a very nice language. Nobody's invented. Maybe Python. Does Python do that? No. I know Python uses indentation, right, to decide on what's a statement block. So this would be in the same spirit. Okay, and that would be actually very good. But that's not the reason why. What's another clue? Because I put another word, final. Lots of adjectives are being put here. You can put, and some adjectives belong to these instance methods, and some belong to these variables. So you can't, and so final is something that you can put both, you can put lots of places, and you can put it here, for instance. Okay? And the word final means that whatever value I give to this variable is its final value, which means the first value that I give to it is its final value, which means it's really not changing once it's assigned, which means it's a named constant.
So is it actually impossible to change my height on there now?
After this, if I put a statement saying my height equals, and I'm growing taller, it says sorry.
Okay.
Java will at compile time tell you, no, you can't do it. Okay? That's why you put all these adjectives, so that you can catch your errors. Okay? If your mind wanders, okay, then this is very good to have such a language. If you're always very alert, Then you say, why are you making me type all this? Why are you making me put my seat belts on? I'm such a great driver. Okay?
So, just to make sure, a name constant is my height, the literal constant is 1.1.
Yes.
So calculate my BMI as a name. Or that's high.
So we are going to learn a lot of, you guys have been programming instinctively. Okay, and now I'm giving you a lot of definitions. Okay? Calculate BMI is a method.
Function.
A method that happens to also be a function. Okay?
That comes from PhD.
So we talked about procedure versus function last time. Okay? You were the one who said what happens when something print lines, does a print. That's a procedure which doesn't return something. Okay? So there's classes, there's variables, there's name constants, literals. I mean, we have this whole new vocabulary here. Okay? And once you have words for these terms, I think then you understand the concept a little better. Okay? Okay. This is my solution. Okay? What's wrong with the solution? It saves me the task, right? I don't even have to enter my height. I just go and enter my weight. Sorry? It can be used only by me. That means for each one of you, we have to write a separate program. Okay, so the whole idea of reuse, which we want in programming, is not happening. So that's the problem. And Marie, what's a global variable?
A global variable is a variable that you declare outside the method. Traditionally, you declare them at the beginning of the class, although sometimes people declare them right above the method in which they're used.
Okay. So a global variable is the opposite of a local variable. When you say something is local, it's local to some scope. So a local variable is local to a method. Because it's local to a method, it's declared either as a formal parameter of the method, as in weight, or inside the method body, as in my height. Okay? Whereas a global variable is a variable that's declared outside a method. Okay, this is just saying what we said earlier. And I'm going to actually, before we go into that, I'm just going to show you the user interface to talk about, to motivate global variables. Okay? So there's calculators and there's spreadsheets, right? When calculators first came around, all the engineers loved it. I mean, they could just, they didn't have to do the calculation. They didn't have to use slide rules. Anybody know what a slide rule is?
It's like just literally a ruler that has the slide in the middle, and you have to like line up 2 points to calculate the
So I'm actually an engineer. Undergrad, I was an engineer, and they didn't allow us calculators in exams, and so slide rules they allowed. Okay? So I've actually used one of these things, and just as they were beautiful because you don't have to do a calculation yourself. So, but anyway, so calculators were fantastic, and then came spreadsheets, and they were just super fantastic, right? So the difference between and so this calculator you see has got a different, this spreadsheet you see has got a different user interface. I've got now, I don't invoke a method. I just see it. Whenever I instantiate a BMI spreadsheet class, I'm going to have a different class now. Since we're going to have global variables, that BMI calculator class doesn't work any longer. Okay? So I'm going to have a different class now, a BMI spreadsheet. And whenever I display it, whenever I say object editor.edit new a BMI spreadsheet, I get a window like this. Okay? And I get a slot for height, weight, BMI, and I can change either of these two variables, and I go and change the weight, and I get the new value of BMI calculated. I go and change weight, I hit enter, and I get a new value. Okay? So this is more like a spreadsheet. It remembers formally. It's a customized spreadsheet. A spreadsheet customized to BMI calculation. Something we wrote, something we'll see in the next slide or so. Okay? But we see here that we want things to be remembered. Okay? And a spreadsheet is something that remembers values in comparison to calculators. So that's the analogy. And in the user interface, you see the analogy literally at work. Okay. So calculate 2 BMIs using one instance of BMI spreadsheet. Okay, so I just used one instance and changed only the weight. And the main point is that when I hit return, when I said weight and hit enter, some function got called that calculated the new BMI, right? That function remembered what existed earlier. Okay, so we want data to be remembered. That's the main issue. That the lifetime of a formal parameter is one method invocation. We want something to be remembered between method invocations. And that's our global variable. And I'm calling them instance variables. And we'll see why they're instance variables in a minute. But just to go back to what Marie said, that calculate BMI is the method which has a body and parameters declared within there. And now we're going to have some global variables, because these variables are outside any method. And we're going to call them instance variables. And guess what? The method that we declared is still going to be able to access. A method can access not only its local variables, but can access also the global variables. Okay? That's why it's global to all the methods in some scope. Okay? So we're going to take something that was a formal parameter in a function, move that to outside the method, and when we move it to outside the method, it becomes a global variable, and we're going to make it a special kind of global variable, which I'm calling an instance variable. And what would the word instance variable mean to you? I know a lot of you have used that term in earlier classes. You instantiate a class. Okay? So a global variable is a variable that is accessible to all methods declared in some class. Okay? Now the question is, what is the lifetime of the global variable? Okay? If it's an instance variable, then the lifetime of the variable is the object, the instance. And if it's a static variable, the lifetime of the variable is the class. When the class got declared, the variable got declared, and it's accessible to all instances. Okay, so there's various degrees of globalness. An instance variable is confined to a particular object, and it's local to that object, but global to all the methods, instance methods in that object. A static variable is global to all instances and can be accessed by all methods, static and non-static methods in the class. Okay? So if you've done Java before, if you've done Python before, this is not new, maybe just a new way of explaining something you already know. Okay? Just what we said. So this is a special kind of global variable. So if I take two instances of BMI calculator, they look identical. Okay, it's like you buy two cars and they are identical when you buy them, and they remain identical for the lifetime of the cars. You can never put any mileage on these cars. And it's like, I got another example here. It's like car radios with no presets. Okay, so the fact that time has passed, there's no memory. Okay? So you have to go and, just as I had to enter my height each time, you have to go and tune the radio each time. Okay? You look at this here, these are two different instances of the same class. And we see they look different. Because this instance remembers values. It has instance variables. You can put different values in different instance variables, okay, of different instances. And so you see that this is like car radios with presets. Okay? So in general, when you do object-oriented programming, you have state, and the word state. So I'm using the word state without defining it. So what intuitively, intuitively only, what does state mean here?
The condition of being.
A bean?
Yes, the state in which you exist. So the condition
Or being. Okay, state of being. So that's the English word. What would the computer science word state mean? An object has state if it has instance variables. Okay? That happen to be non-final. Okay? So that's basically what's. So in BMI calculator, we had no variables, instance variables, so there was no state. Okay, so that's conceptually, graphically, and now you see exactly how you might declare an instance variable. So you declare it outside any method body, but inside a class. And as Marie said, you can put them all in the beginning, or you can have the variable, then declare something else afterwards. The dot, dot, dot means some code. Declare another variable, some other code. And then you can have your function here, get BMI, that accesses these variables. Okay? We haven't seen the whole class BMI spreadsheet, but we at least understand what an instance variable is at this point. And we understand there's a new method get BMI that we defined that's different from calculate BMI. Okay, but in both cases we're calculating BMI. Okay, questions so far? So private or public? Let's get into that. Let's not get into private. Let's get into public right now first. Can I put the word? We put the word public here, adjective public here next to this method. And by putting the term public next to this method get BMI, what am I really saying? So you can access this method get BMI outside this class. In particular, that means a class called object editor can access it. Okay? If I did not put the word public, I didn't put the word private. Okay? The opposite of public is not private. If you had only two values, then yes, one is the opposite of the other. But we have 4 levels of accesses. Okay? So public is the most liberal access. Now, can I put the word public in next to a local variable? We don't have a local variable here, but if we did, can I put the word public next to a local variable? The lifetime of the method, of the variable is the method. While the method is executing, you can't quite access the parameter value. Okay, what would it even mean? Okay? So you can't put the word public next to it. That's why the question, should it be public or private, didn't exist. Can you put the word public here? Does that make sense? The lifetime is much longer. Okay, you can, after you call a method, you might go and access. You can't, while you're calling the method, you're in the call, you're stopped. You can't do anything. You can't access the variables. But after a call, you could conceivably look at the variable and see its value. Okay? So, it's legal then to put the word public here?
Yeah.
Has anybody ever declared a public instance variable? You were going to put your hand up, but you have? How many points did you lose? So, Java allows us to make it public, but our TAs and lecturers are just, they don't let you speak certain words. It's like Brave New World, if those of you read the book. Okay, you just speak newspeak. Okay, you don't have certain bad thoughts that way. Okay, so we don't let you. You can have, we don't let you put public next to it. Why not?
Some variables are related, and if you change one of it, the other wouldn't change. Just directly access the variable.
So, some bad things could happen, right? And that really means that if you have some thoughts, just keep them to yourself till you figured out what you really want to express. I mean, that's one philosophy in life. The other is just to blurt out whatever you think about, right? And maybe people feel more comfortable with you that way. So, but the thing is that if you blurt out a thought, you can't change your mind later about saying, oh, I never said that. You can't deny it. It's all over. Okay? And if you're running for some important post, you're in trouble. So it's the same thing going on here. Once you've exposed certain things that don't need to be exposed, you can't change your mind about certain things. Again, we'll talk about changing our mind a little later. But for now, changing our mind means, how do we implement a class? Somebody tells us how to, here's the functionality I want. Here's what I want the class to do. Okay? And how do we express that? We'll see that in more depth later. And you would like to change your mind about how that functionality is provided. You don't want to commit yourself to anything. And so there's also a principle in military called the need to know principle, that we don't tell you anything that you don't need to know. Similarly, a programmer, when you're writing a class, you don't want other classes to know things about your class that other classes don't need to know. Okay? And clearly, if I make a variable public, they get to know your variable and access the value. So there's more knowledge being given to other classes. And generally, when you write a program, you're writing a program with multiple classes, and you want what's called the coupling between the classes to be as low as possible. You want each class to know as little about the other class as possible, because then you can change one class without changing the other class. Okay? So yes, you can declare it as public, but we won't let you do it. Okay? And we'll see exactly some reasons for why. It's not just an arbitrary rule. Okay, questions?
So do you recommend it for private or just leave it?
So we don't know what private means. Okay? So just don't do anything. That's less typing. Okay?
Okay, so if you declare it as public, can another program or another object go in and change the value while you're executing?
Another class,
Another
right?
class. So
Yes.
go in and
If
change
it's
the
declared as public, non-final, just public,
Okay.
then the other class has as much access as this class. Now you know why things can go bad. Okay? And we'll see. I'll give you concrete examples of why things can go bad. Okay, so get BMI is a function with no parameters, okay, because it accesses these global variables. Let's try to understand this. Okay, so the whole thing, let's continue with this. So we did not declare double to be public, okay, yet we want a BMI spreadsheet user interface to show the height and weight, okay. That user interface is created by object editor. Object editor is just another class. Okay? Object editor needs to be able to show the BMI value. Okay? It can do that by calling getBMI, which is a public method. So this value it can fill. But the height and weight, it needs to fill also, but this new speak we are speaking doesn't allow us to go and use the word public. So how do we have a cake and eat it too? You have to define a mutator and an accessor. What's an accessor? What's a mutator?
Those are basically methods that allow you to either view what the value is and change.
So we have defined, we have said you cannot declare public variables, but you can declare public methods. You say, okay, how do I live with these constraints? Okay? So the only way I can go and export state is through methods. So I will define a method where when somebody wants a value, I'll define a special method that returns the value of a variable. So it accesses a variable perhaps, and that's why it's called an accessor. And since these variables these have to be changed also, we'll define a special methods that go and change the values of these variables, mutate them, hence the word mutator. Anybody used a different term for accessor and mutator, something that's more direct? Getter and setter. Okay? And given the nomenclature we have here, the getter method seems more reasonable, right? So outside access object editor, and that's not allowed, okay, because we have this thing against public variables. Okay, like I said, variables should not be public, like hidden thoughts, but object editor needs their values. So we'll define a get weight. Object editor will call get weight. Okay, now I told you in one of the earlier classes, the computer science is all about indirection. or a lot of computer science is about indirection. We are not accessing the variable directly. Rather, we are calling a method that then accesses the variable. And this level of indirection is what gives us a lot of power. Gives us the ability to change our mind later. Okay? And returns the value weight. Similarly for height. And we'll define a setter method. The value that you want to assign will be passed as an actual parameter to set weight, which will go and write to a formal parameter, and hence we'll get our ability to change state. Okay? Get BMI. How does it compute its return value? What variable does it access? It accesses two variables, both height and weight. Okay? And it's something you can't set. Okay? You have to change your weight and height. Okay? Otherwise, you can't change BMI without that. Okay? And here's some code. And this code is not complicated. Get weight is simpler than get BMI. Get BMI accesses two variables. Get weight accesses only one variable. Set weight takes takes its value and assigns that to a global variable. So it got a value in a local variable. It took that value and assigned it to a global variable. So that value could be remembered. Okay? Questions? So get weight is a function. And if that's a function, set weight is a procedure. We saw last time function and procedures. Main was a procedure, and calculate BMI was a function. Okay? It returns nothing. That's why the word void. Okay? So your getters are special kinds of functions. Okay? Calculate BMI is also a function. So is a getter. And a procedure, setters are special kind of procedures that set the values of it. That set values. Okay? Everybody understand the difference between function and procedure? Okay, that's 110 stuff, 101 stuff. Okay, let's see. So here's an analogy. So in a teller machine, when you withdraw money, you're getting something, right? So that's like a function. And when people use analogy of a method, they say, I use the analogy of functions. A method is like a function. And another analogy is recipes, right? It's a set of actions you do. Okay? And that analogy works well for procedures. So sorry, here I'm depositing money. So that's a procedure. I don't get anything back, but there's a sequence of steps I follow to go and deposit. And this is a function, and I get something back. Okay, and that's like a mathematical function, and procedures like a recipe. So methods, people use both kinds of analogies, depending on whether they're thinking about functions or procedures. Okay, going to see some new terms here. Now I've got calculate BMI. That's a function. I've got get weight or get BMI. That's a function also. Can you see some difference between these two functions? And one is more pure than another. One is more mathematical. If you had to take a guess, which one is more like mathematical functions, which one would you say is more like that? Calculate BMI? Why? It's all accessing only local variables. Whereas, when you talk of mathematical functions, do we talk about global variables? It's all parameters. Okay? Sorry?
You access more than one variable.
So here we are accessing two parameters. And here I'm accessing no parameter, but accessing one variable. So that's another difference, that this is two and one. But that's not what I meant, okay? Because they will calculate BMI and square are both pure functions. One takes one parameter, one takes two parameters, but they're both pure because they are confined to their formal parameters. Whereas here, this is a funny kind of function. Okay, it's something between a procedure and you can think of procedures as manipulating variables or printing out things, whereas functions as global variables. Whereas functions you think of as methods that just take your formal parameters, look only at those, and return a value. Okay? So this is more pure. If I call calculate BMI with some formal parameter, with some actual parameters, I get some value. Now I execute some more code after that. Who knows what that code is? I do calculate BMI again. What value will I get back? Guaranteed, because it's a pure function. I do get weight. I get 77. Who knows what I do here? I do get weight. Am I guaranteed to get 77? What bad things could I do, or what interesting things could I do? Sometimes bad things are interesting, right? In dot dot here to make. So I had done a set weight here. That's why I got 77 there. Okay. So you get that? You saw the difference? Yeah. I clicked too fast. Was that confusing to anybody, what I did earlier? I mean, calculate BMI always returned the same value, whereas get BMI returned different values. Was that confusing? Nobody got confused? I called it get BMI. Because what do you expect? Or get weight. You expect it to return the current weight, right? The naming was such that you wouldn't be surprised. Okay, but a lot of people think this is really bad to have impure functions. In fact, people have created programming languages. You know, we are banning the word public for instance variables. They've created programming languages where you cannot have impure functions. You can't have procedures for sure. Okay, but you can't even have impure functions because they think they're confusing. Okay? And anybody know what kind of languages these are called? So Java is an example of an object-oriented language, and examples of non-object-oriented languages. I mean, what is the term? Non-object-oriented language? Functional language. Anybody know an example of a functional language? C? No. No, not visual basic. Pascal, imperative language. C, imperative language. Basic, imperative language. These are pure languages. And basic. You know, you guys are getting more and more non-functional. You tell somebody who's into functional languages that a C is the functional language, they'll cringe. You say basic, they'll cringe even more. You say assembly, they'll just go nuts.
Lisp, R,
Very good. Lisp. Scheme, ML. And they all cheated a bit with functionness. And the most pure functional language or language called FP, standing for functional programming. Okay, and why these purists around? Let's go and look at this. Once you have impure functions, you can do really bad or interesting things depending on your viewpoint. Okay, so what's happening here? I have a get number and a set number. Okay, straightforward. Then I'm trying to be very clever after that. Okay, I've got to do square. Square is number star number. I could just say return number star number, but I don't do that. I go and remember the value that existed. I remember the value so that next time I call square again, so that's what I remember the value for who knows why. Then I look at cube, and cube says, look, I'll just say return value is square star number. So get square would have remembered the square value, I take that value and I don't want to go and do number star number star number. So I'll just look at what value was computed earlier, what value was cached, if you will. Okay? Caching is all about state, right? To remember things. And I'll go and print line, you know, for debugging what the return value is, and I'll return the value. Okay? So I try to be very clever in square and cube. In square, I didn't just return the value, I assigned the value to a variable, and that variable is then used in cube. Okay? Clever programming? You don't like it?
Well, if you execute get square for some number, and you decide to change that number with your set number function, then you use get cube.
Get cube will not return the right value?
It'll be the square will still be with the number, the original.
Okay, so let's just take a simpler example. I say set number 5. Okay? I say get cube, what value will it return? 0. What was number initialized to? 0. I didn't declare it, I just said int number, but that means int number default value is 0. And get cube is just going to say 5 multiplied by 0. Okay, I didn't get the right value. Okay. I go and do a get square, I get 25. Now if I call get cube, what will I get? Then I get the right value. So I was too clever for myself. And this happens a lot in programming. This is because I allow in my language impure functions.
Then all that impure functions are is the purity of the value of whatever you're receiving, right? How much can you trust what you're receiving? Pure functions, you know exactly what you're getting. Impure functions, you have no idea. It could be.
Impure functions, since you're looking at things that are not the regular variables, who knows what you're looking at, and it gets confusing. Okay? So we are not going to be like FP and say ban impure functions. We're going to just have some rules in class. Okay? Oh, did you have a question? Other questions or comments? So I use the word pure function, I've used the word impure function, I've used the word side effect. Anybody want to? Now, the word side effect we see a lot, we hear the term a lot in the context of drugs, right? And what is the side effect in the context of drugs? So there's an intended effect, cure your headache, and the side effect, do damage to your intestine, right? So that's not the intended effect, and it may happen, it may not happen. Okay? So when you're doing something that was not expected, you have a side effect, and that's when you gets confusing. So I'm going to argue that get number has no side effects, but get square and get cube have side effects. They're all three impure functions, but they are bad to different degrees. Okay? Because they have different degrees of side effects. And I'm going to argue, so we'll have to figure out what side effect means. I'm just giving you an example of how I would use the term. I'm going to say get number has no side effects, but it's an impure function. And that's fine. Impure functions without side effects, go ahead and use them with abandon. Impure functions with side effects, absolute no. Okay? So what's a side effect in the context of programming? Marco?
Unexpected behavior?
Yeah, but it's unexpected behavior, but a little bit more detail.
When you get an unexpected value?
When you get an unexpected value. But, you can be very clever and get the expected value. We won't allow you to be clever also. Okay? Because we are not clever enough to look at your code. Okay? So we ban you from giving even what you think is expected, because so they're all three functions, but they're different in some very syntactical way. You can look at this code and say, yeah, this one's got this side effect, this one's got this side effect, and who knows what might happen. Marie?
Functions with side effects are functions that
perform an operation. But what's an operation? I mean, computing a value, that's an operation also, right? But you're on the right track.
They're computing a value with a variable that can be altered, not with sign.
But get number is computing a value
Right.
out of a variable called number that can be altered. But you're on the right track. That can be altered. Use a passive voice. Passive voice is great. You know, you never assign responsibility. Okay? Let's assign some responsibility. Let's use the active voice here. They're computing a value and they're... Let's look at square. That they're doing, that all of these functions are doing that. Sorry, say that again. But that's what Murray said also. Get number is using a variable that can be used by the active voice. You're taking responsibility. The function is not only computing value using an alterable variable, it's altering the alterable variable. It's altering a global variable. It's performing an operation intuitively. Okay? So it's got a side effect. A function should just be returning a value. It should have nothing else. It should do nothing else but return a value. That's what getNumber does. getSquare says, oh yeah, I'll return a value, but guess what? I'm so smart, I'll go and change a variable also. Okay? And we got into trouble. Now you can program this thing differently to make it return the right thing and still have side effects. Okay? But it's doing that. Now getCube, is that a function with side effects? No. It prints something. I call it once, I call it 10 times, I get different results. There's a pure function, if I call it successively in 10 times, the world doesn't even know whether I called it 10 times. Okay? So it's also printing something. That's a side effect. That's a procedure-like thing. That's an operation. Make up your mind. You want to return a value or you want to do or print a value? But I'm going to say this is not as bad a side effect as this because it's only active because the behavior of other functions will not get changed. Okay? And if you're debugging a function, you put print lines there anyway. So if you as long as you put just debugging output in a function, that's okay. Okay? So what's a side effect? Side effects are things we associate with method invocations, so with methods. And when you have a function that changes global state or does some non-debugging printing, then that function has a side effect. Okay? And we see the two. And it makes a function behave like a procedure, so it's more impure than a regular impure function. Okay? These are banned. You cannot have side effects. Okay, in the next assignment or the assignment after that, you'll be tempted to have side effects. Please don't. Okay?
That's where getting more abstract, creating more functions, allowing us to do that.
To some degree. Yeah, have a separate method for printing the value and have a separate method for computing a value. This is called the principle of separation of concerns. If there are two logically different things, make them physically different methods also. Okay? It all has to do with sort of, breaking things into smaller parts and then making sure that there's not too much coupling. And it's a challenging thing to do, but at least we know what to do. How to do is hard, but we won half the battle by knowing what to do.
So you want us to instantiate every class with all the immutable data that class needs to the entirety of the program we're running.
I just don't want you to have side effects. Okay? That's a more direct way of saying that. Because what you're saying is more restrictive. Because, yes, you'll have, it's not only mutators and accessors in a class, there are many other kinds of functions also, these methods also. Okay, so let's just don't have side effects. In particular, in your getters, Don't do funny things. Okay? And don't instantiate objects also in your getters, which is a form of side effect because it's changing memory. Okay? So getters should be just computing values. They shouldn't be instantiating objects. Objects get stored in memory for a life, for much longer than the lifetime of the method. Okay? So don't do that. Okay. You guys, I'm just curious. Have you heard the term side effect in earlier class? How many of you have heard the word side effect in earlier class? No? Sorry? Privacy leak? No, that's just totally different thing. Okay. Okay, so I'm using the passive voice. Side effects should be avoided. So there's a degree of purity. Pure function computes a value, does not access global variable or produce non-debug output. Impure function can use a global variable but doesn't write a global variable or do printing, or does not write a global variable. Actually, does not write global variable and printing, I should say. Impure function with side effect computes a value and does these bad things also. And procedure returns nothing. Okay? So it can do anything. A procedure, you can do anything. No. So I'm not saying have no state. Okay? You're allowed to write procedures. It's very difficult to program without global variables. But if something can be a local variable, please don't make it a global variable. Okay? Because that increases the coupling between the methods in a class. If it's possible, if you don't require them, don't use them. But typically they also lead to efficiency benefits. So as long as you go in, don't create side effects. That's what I'm saying. Because it's very hard to do interesting object-oriented programming without state, without global variables. And that's exactly what these functional languages ban. Okay? And they get into a lot of trouble. Okay, that's what I don't allow. Okay, we think we know what getters and setters are. Let's try to figure out what they really are. A getter is a method that returns the value of a variable, of a global variable. Anybody argue with that definition? It can return a value of a local variable too. If I say get pi, where pi is the mathematical constant, that can be just burnt in, right? It can be a static constant. I can just put the word 3.14 whatever it is, and that's also a getter. So that's interesting. Do we see here in this class example of a getter method that doesn't return the value of a variable? Get BMI. What does it return? So it returns the value of what? Well, operation is something that returns value.
So a getter method does not alter the state of the object?
Yeah, okay, so that it doesn't.
And it returns value.
So so calculate BMI with two parameters, would that also be called a getter method? So calculate BMI with two parameters, would you call that a getter method? It's not a procedure, it's a function. It's returning. Calculate BMI, returns, takes height and weight, returns the value. It's confusing, huh? So mutators, accessors, you guys all jump with those terms. We don't really know what they mean. Okay, so what's the title of the slide? Somehow can we tie this all together? Can we define a new term? So when you use the word property, well, that's very generic. The word property in computer science is also used for many things. But let's try to use the word property, give it a definition that could somehow allow us to define a getter and setter. So a getter method returns the value of a variable. We didn't like that. Substitute the word variable to something.
Just return some value, not necessarily a variable.
But if it returns some value,
Yeah. Then they get it.
can it take parameters? So calculate BMI would be a mutator? Oh, sorry, accessor?
No, I think getter just like directly return
Of a variable, of a, leading you to the word, of a property, whatever property means. If you can define that correctly, then we know it returns the value of a property. And a setter method sets the value of a property, whatever that means. Okay? So, difference between a property and a variable.
Editable?
Sorry?
Editable?
Yeah, if you can set the value, then the property becomes editable. Just as you have a non-final. Property is also named. That's a key here. If I was to say get BMI returns the value of a property named, you see there's a, and get weight returns the value of a property named weight. So properties are defined entirely from the public methods. I can look at all the public methods of a class and say these are the properties without knowing anything about the variables. Variables are hold state, are associated with state. Properties are associated with state also. Variables are things that are accessible inside the class, typically not outside the class. Properties are things you derive from the methods. If the methods follow certain convention, naming conventions, then I can look at the method and say the properties of this class are height, weight, and the variables of this class are height and weight. And just as a variable has a type, a property has a name and a type, just like a variable. So the type of BMI property is, the type of weight variable is, how did you know that? Of what? No. What about BMI? How did you know that? From which method? Accessor or mutator? In case of get BMI. In the case of weight, you knew the type of the property from the accessor, and you can't look at global variables. You can't look at variables to declare the type of weight. So you could figure out that the type of weight is double from get weight, and by looking at which method? That's get weight. There's another method also, right? Set weight. What in set weight tells you that the type of the property is double? The formal parameter. In the case of setter method, the formal parameter tells you the type. In the case of editable properties, which we talk about, and in the case of these getters, the return value tells, right? So there's read-only properties and there's editable properties, just as you have final variables and non-final variables. Okay, it's a typed unit of state, and it's a named unit of state, just like variables, but exported state rather than the private state. Okay, as far as the user of BMI spreadsheet is concerned, for all you know, there's a BMI variable inside. There could exist one. Okay, and so it's got a name, say P, and so if I want to declare a property named P of type T, what kind of getter method should I define? What will be the header of that method? Okay, and if I define only a getter method, then that property is read-only. If I want to make it editable or writable, What kind of method, what is the header or signature of the method I would define for set? Again, the name of the parameter doesn't matter. Okay? And the P there and this P better correspond. Huh? And what other things should correspond here? Sorry, I'm going backwards. And the T and T. Right? And that's a getter method, that's a setter method. What if I change the method from get P to obtain P? It's okay? It's not the convention. You know, when you write English and you want to use the word get first in a sentence, and you need to use the same word, same concept again, and you don't have a good vocabulary, you just use a thesaurus, right? You say it's boring to use the same word again and again and again. Well, in computer science, we are really boring. Or let's put it this way. We don't get our interesting things by naming. We like clever algorithms. So that's what makes us interesting. Okay? But we want these names to be boring so that there's no challenge in figuring out what you really mean. If I don't speak English, I don't want to learn another word called obtain. Okay, I figured out get. Okay, I'm happy with get. Okay? And so there's conventions. And what kind of conventions? It's not following the conventions. Do these conventions have a name? Anybody heard the term? Bean convention. Okay, Java created these conventions, and it's called the Bean conventions, and we'll require you to follow the Bean conventions. Okay, and these conventions are good for humans. Okay, because there's no challenge in understanding. They're also good for tools, because a tool can mechanically go look at your program, a tool like Object Editor, and then go and figure out what your getters are, what your setters are, and create a user interface out of it. Okay? Okay, you stop it. Okay. Questions?
Assignment 3, when you say that you want to print the object using print ln, do you want the display to be where it says class at and hexadecimal memory space?
So the question is, how do I want the object printed?
Yeah.
Printed as Java printed. Okay? So that's what I said. That's why I put dot dots. I don't know what's going to come out. Okay? Other things? Okay. So your assignment 3 is on properties, and if you've already started working on it, then you're pretty conversant with them. But let's just look at them in a bit more depth to really understand them. And we saw that there's a notion of the abstract notion of properties and certain conventions for defining them. Okay? So the abstract notion is that it's basically a named type unit of state that's exported. So it's unlike a variable, which is not exported, which is not public typically. So you do want information, you do want a logical state to be manipulated by other classes. So that logical state comprises of properties. Okay? And and you have to somehow convey to an outside class what the properties of an object are. And the only things we allow you to export or make public are methods. Okay? So somehow through the method declarations, the properties have to be derived. Okay? And we saw conventions that if you've got a property P of type T, you should have a method called getP that returns a value of type T. And that would make the property editable, read-only, if you just had that method. If you also wanted editable, change from the outside, then you declare a method called setP, which returns no value and takes an argument of type T. Okay? So there's a relationship between the getter method and the setter method of a property. Okay? And these conventions are the Bean conventions. You can violate them a little bit maybe, and other humans can still understand what you're trying to say. But we also have tools that go and use these properties and do interesting things with them. And object editor is one such tool. So you have to be a bit more, you have to really follow the conventions for object editor to work. And the reason why these are called Bean conventions is because Java also had a tool called the Bean box that made the same exact assumptions. So from that tool came these conventions, and these conventions can be used for other tools also. Okay? So any questions on this so far? Okay. So let's just see whether we understand. Let's look at these properties in more depth, and let's also see. So let's look at this BMI spreadsheet and classify the properties. So height is a property. What are the other properties we saw last time? Weight and BMI. And we also saw that object editor creates a certain user interface to display and manipulate these properties. Okay? So let's look at this code here, and let's look at the user interface and try to figure out how our object editor exactly works to make the user interface, to create the user interface. Okay, so the user interface, if you use object editor, is the following: that you have here a slot for height, weight, and BMI. BMI cannot be changed, okay, because it's not editable. Whenever you change height, the BMI is recalculated. Okay, so when you edit height and then hit return, at that point the new BMI value is. Okay, so somehow all that stuff happens by magic from this class declaration. So let's demystify this magic. What exactly is object editor doing to make this user interface happen? So let's go and see. When you first display this object, the height, weight, and BMI values, slots are created, and these values are displayed. So what must object editor be doing with your class to make that happen? We'll look at the dynamic interaction later, but how does it create the initial user interface? Sorry? So it somehow figures out the properties. It could scan through the program, or it could use something called reflection, okay, where it just the compiler has created data structures that can be used at runtime by object editor, and that's done through reflection. Okay, so it somehow figures out what the methods are. Okay, and from those it figures out what the properties are. For each property, it creates a slot. It knows the name of the property. Okay, so it can certainly go and create these slots. And how does it know? How does it figure out the values of these properties? Sorry? Through the getter. So what must it be doing? It must not only learn what the properties are, but it must also have a way of executing the getters. Okay, so it has to somehow be able to call the getter. Again, that's done through reflection. Okay, so it calls, for each property P, it calls get P to return the value, get the value, and it displays those values. Okay, so that's the initial user interface. Now let's say I go, so it calls get height, get weight, get BMI, and it gets these values. Now let's say I go and change weight from 71.0 to 77.0. Okay, and we see that the BMI value got changed. What must be happening at this point? Or what could be happening? Okay, so because you changed weight, and it is an editable property, it knows the string the user entered. It uses some way to convert the string into a double. You guys have seen that for integers you can use integer.parseInt. There's something equivalent for doubles also. So it converts that into an int value, into double value, and calls set weight so that now that object has a new weight. Okay?
How does it know call set weight, or how does it know to recalculate the BMI after you call set weight?
Okay, so that's the question. Okay, that's this part. So far it was easy. That when you do set weight, it just changes weight. But now it has to call BMI, get BMI somehow to go and return the new value. How does it know to call get BMI? I'm going to pose the question back to you. It executes all the methods.
Well, yeah, I mean, that would be the simple way to get it.
That would be a simple method is called a brute force method also. So it calls all the methods or certain kinds of methods.
I guess we would call it get.
It could call all the get methods, just in case some value is different. Simple brute force approach.
So we're changing weight. If weight changes, can it tell where weight is used in the classes that it uses to get this output?
So there is a naive brute force approach and there is a smart approach you want. And you say, let object editor be smarter. And could it not look at the code of get BMI and set weight? And it says that, look, set weight is changing weight here. Get BMI is using weight. So let's call get BMI, but let's not go and call get height, because height is referencing a variable that is not changed by set weight. That would be much smarter, right? So it doesn't do that. Okay? I wrote it. Maybe that says something about me. So why do you think it doesn't do that?
Because it would be very difficult to figure out whether or not one of the properties is affected by changing other properties.
So it would be very difficult in general. It seems in this case you could figure it out. But it could be very difficult in general to look at a piece of code and figure out whether it does things like that. How difficult? Impossible? Very difficult? Oh, so you're saying doing the calculations, it would be difficult, but it would be expensive.
Yeah.
And you'd rather do the brute force approach
At some point.
rather than do this. Okay? Now that stuff I can do when the program is written. I can do it offline, when you're sleeping. Okay? And when you're using the spreadsheet, I could go and be more efficient. But you're right, if you're going to use it only once, if you're testing, debugging, you're trying to modify your program, that's a cost you'll have to pay. So we think it's difficult, we think it's expensive. Anybody think it's impossible?
Well, if get BMI calls a private method, it could be impossible.
Okay, so so now the question is, what information is even available to Object Editor? As it turns out, Object Editor cannot see this code. Okay? So we are wondering if it could see the code, could it do something? And it can't even see this code. All it can see is what's the header? Okay? What is the name of the method? What is the types of the parameters? What are the parameters? And what's the return value? Okay? So even if it was easy, difficult, whatever to do, Object Editor can't do it because this information is not available to it through this reflection API. It could have gone and looked at the source code and done these things. And then the question becomes, is it possible or is it impossible? So if it could look at the source code, then private versus public doesn't matter. It could look at everything. So assuming it could look at the source code, how difficult do you think it is? Anybody think it's impossible? Let me pose a simpler problem. You guys all write code, and the TAs have to painstakingly grade it. It would be nice if you could have automatic programs to grade other programs. Before we talk, and in some cases you can do that, okay, by looking at the input and output. But it'd be nice to go and look at the code and figure out if a program works correctly or not. That's pretty ambitious. Let's just say they just want to write a code to see whether your code your main method halts or doesn't halt. Simple thing. Forget whether it computes something correct or not. Just whether it will terminate or go in a loop forever. How difficult do you think that would be? Impossible? You know that? What's the problem called? Infinite. So why do you think it's impossible? Just your instinct? Oh, so you're saying the computer will run the program to figure out whether it halts or not. No, I'm saying the computer will analyze the program somehow. Look at these variables, look at these dependencies, do something intelligent. Yeah, if it just runs the program, then it could look at your program. It doesn't have to run your program. After all, the TAs do look at your code without, they run it too, but they can look at your code to figure out what it does.
Oh, if it's the computer doing it, then if it gets stuck in an infinity loop, it can't get out, right?
So that's what you guys are saying, that the computer will figure out whether your program halts or not by just running it. But I'm saying that your computer could analyze it, just like a compiler analyzes your program.
You could have a program that just looks at it like a text,
Yes,
and it looks for keywords, like the exit or break or something.
right.
And if it doesn't have that, then you haven't set it.
So you're saying maybe it is possible to write a program that looks at another program without running it. Okay?
Just look at it like a text.
Yeah, just as you and I would look at somebody's program and say, hey, yeah, I think that halts. I think doesn't halt. Computers are getting smarter and smarter. Sometimes they're getting smarter than us also. Okay, so maybe if we can figure out if some program halts or not, maybe the computer can also figure out. Okay? Anybody know for sure that this is impossible?
Well, thinking that I don't know any IDE that does that already. It seems like the computer is still not able to analyze logic errors. Syntax errors, yes, but not. I don't think they can really analyze your logic.
So the computers aren't that smart. Good for us, right? It's called the halting problem. Okay? That many people wanted to do these things. Okay? And then somebody said, here's a proof. And they gave a mathematical proof. And it's involved. You have to go and take, theory of computation, of course, the offer here, to figure out how the proof works. But you can't even write a program to analyze another program to see whether that other program halts or not without running. Okay? So if you can't say whether it halts or not, how can you go and say whether what properties it affects or not? Now in this case, there's no problem. But in general, that is a problem. And the problem occurs because you have breaks, because you have loops. And yes, you can have breaks in them, and the breaks say that maybe it'll exit the loop. But just because you have a break in a loop doesn't mean that you'll actually. Okay? So Object Editor takes a very brute force approach for two reasons. Firstly, it can't even look at your code through Reflection API, and it doesn't get into compiling your program. And secondly, even if it looked at the code, in many cases it would fail. Okay? In some cases it would fail. If you don't put any loops, yeah, sure, it can do it. Okay? So it will take a brute force approach. But we'll see later when we look at a certain pattern called the observer pattern, that you can tell Object Editor, look, whenever height changes, these properties get affected. So it can take a smarter approach. Okay? And that is something you will need anyway if you want to do animation. So that will be the perfect solution. And for now, we'll work with the imperfect solution, which is that we refresh all properties. Okay? Question? Now, I said this is the case, and let's say you are, cynical, or what's it called? Trust but verify. So you want to verify what I just said. You don't take my word at face value. How could you figure out yourself whether what I said was true or not? You can't look at my code. Okay? But you can still determine whether my code, at least on this particular program, does what I said. So what do you want to determine? You want to determine whether first, when the user interface is created, all the get methods get called. Could you verify that?
You can set a method that is give a random number.
You can do random numbers, but why do you want to do random numbers?
So if the random number doesn't refresh, which means basically it's going to call all the method.
Hang on, where are you going to put the random number here?
Get another, maybe get random number.
No, but just for this spreadsheet, tell me, how can you verify that when object editor is given an object, all the get methods are called? How could you determine that?
Add a print statement that just says it's called.
Just put a print statement in a get method, right? And then you can similarly put print statements in set methods to verify whether all of this stuff really occurs. Okay? So, or you could put, if you didn't want to put print statements and you were a really sophisticated programmer, what would you do? Breakpoints. Okay, you could do that in debugger, but then you got to take screenshots and so forth. With print line, you can just have a little trace. Okay, so we'll do that. So this is what's saying when weight is called, it calls set. When weight is changed, it calls set weight, and then that calls get height, get weight, and get BMI to refresh. Okay, I just said in graphics what I said earlier. And let's verify this. So now I just put these print lines, and I put set height called, get weight called, set weight called, and get BMI called. Okay? And these are tracing the methods. These are just debug output. There was a question in the Piazza, what's debugging output? Output is something that comes out of the console. Okay? It's not a return value. And if the intention of that output is to help you debug your program rather than give the user something useful, then it's debug output. Okay? And let's see what happens. Okay, when we do what I said earlier, we did. Okay, we went and first displayed the object, and then we changed set weight. Okay, so before we did anything, there was get weight, get height, get weight, and get BMI called to get these initial values. And here is when we call set weight, and right after calling set weight, get height, get weight, and get BMI were called. So why is get weight called a second time? Because I edited, that's very good. Okay, because I edited, because I called set weight, because the user changed weight, object editor before calling set weight calls get weight. That's really the reason. But why? Okay, in case there is weight has got a different number from when you first called. Okay, because another object could also go and change weight. It's not just object editor. So before it changes weight in the object, it wants to remember the last value weight was. That's exactly why it's called. Or why does it want to remember the last value the weight was?
Because if weight hasn't changed, it doesn't need to do it.
Okay, that's a good point. That if weight hasn't changed, it doesn't need to call set weight. Okay. I used to have that in the user interface, and people didn't like that because they wanted to enter the same value again and again. So I changed it. Okay, but that optimization, as it turns out, was not a good one because people wanted. But that's a good reason. Okay, another reason. Okay, so you're saying that what if the user entered an unacceptable value for it? Okay, in that case, it wants to replace the current value. That's a very good reason. It wants to replace whatever you entered with the last legal value, so that at least what you see is correct. But would you want that in the user interface? You were editing for weight and you added an I rather than a 1. Do you really want the I to be changed back to the original value, or do you want to just edit that I and that was a typo probably? So, but that could be a very good reason if the user interface, if that's a user interface you wanted. Okay, but maybe that's not the best user interface. So when does a computer, almost all interesting programs remember what you did? Because there's a very powerful command these programs provide that is wonderful. Undo. Okay? What if you go and want to undo? And object editor has undo support built into it. So what it does is that it remembers the old value just in case you do undo. Okay? So that's just a subtlety. So this is the initial user interface. You're changing weight here, and this is the extra call, and it's called by the undo redo mechanism in object editor. Okay, okay. Let's really understand this refreshing thing properly. Here's what you did. You created a new BMI spreadsheet. You asked object editor to display it. Okay. At that point, the BMI spreadsheet where the height and weight are zeros. Okay, we didn't assign any values to them. No setter has been called. And so you see 0, 0, and NAN stands for? Not a number. Okay, 0 divided by 0, who knows what that means? Okay? So it's not a number. Then after object editor.edit, you said BMI spreadsheet.set height 1.77, BMI spreadsheet.set weight 75. Okay? But nothing changes here. Why not? Okay. So that set height and set weight were called by your Java program. The fact that you called this code is unknown to object editor. You did not call set weight and set height through object editor. When you call it through object editor, it says, okay, I know set weight was called. Let me call all the getters. Okay? So this happened unknown to it, and it displayed what it was given, and then later some code ran, which it knows nothing about, and as a result, it did not go and update. Okay? So what you see on the screen may not be what you actually have in your object if the object is manipulated through some, through some object other than object editor.
Does this mean that we don't want the main object to run all of our sub-objects?
So does it mean we shouldn't write such code?
Yes.
Or it means object editor should behave better. Okay, you want to write such code. Okay, so we need to do something else. We need to get the object editor involved. So what could you tell object editor at this point to make it change? It just needs to be told something. Yeah.
You can just put the BMI spreadsheet set weight or set height and set weight inside the.
So
I don't know if you can do that.
you're saying do these two things before you say edit.
Well, just like put those as the input.
So somehow pass these values when the object is created, and we look at constructors that will allow us to do that. That's one way. Or you could go and call these set methods before you say edit. That would do it too. But sometimes while you are interacting with the object, you want the program to change things too. Okay, if you want some kind of animation, that's what happens. Okay, that the thing is changing while it's being displayed. So what else could you do if you're designing object editor? Yeah. Have a refresh function. Okay. So here setters are not called through object editor, so it does not know it should refresh. That's the keyword. Okay. So what we did was we took the return value that object editor.edit returns some value. Typically we don't care about the return value, but that return value is of type OE frame. Okay. That's an object editor frame rather than a regular frame, and you can just say OE frame.refresh. Okay? And that will tell object editor to call all of the getters. There are better methods to do this. Look at this message here. Whenever you do this, you'll get a warning message saying you're being bad. Okay? For now, ignore this warning message because you don't know how to be good. Okay? But later when you talk of the observer pattern, you'll see that you won't just say refresh, you'll say refresh this property. Okay? Or refresh that property. And that's much more fine-grained. Object editor can be more efficient that way. This is a brute force approach. And for now, and I guess I have to correct a typo in my error here. So that's the way to do it, and you'll see that this works. Okay, so better ways to. Questions so far? Okay. So why might you want to actually change values in your object after you displayed it? Okay, one reason could be that I've told you guys to create a video, okay, of your object running. Okay, and you probably manually went and changed the values and recorded yourself if you'd made a video. Otherwise, you did a screenshots. Wouldn't it be nice if you could just feed the values in the program, okay, and have the program test object editor with different weights and heights, and let the users see those values changing, okay, in an animation fashion, okay, because you don't want it all to happen so quickly that the human can't even see it. And this program here is doing that, and let's try to understand let's try to understand this program, okay, so, and see some additional features. I said create a new BMI spreadsheet. I want to first try out the values 1.77 and 75. Okay? So I go and set these values, and I say object editor dot edit BMI spreadsheet, and you'll see these values. Okay, that's the initial value. So we know the TA knows that at least on these two values you had the correct BMI. But you want to show the TA that even on other values it will work. Okay? So you went and changed your weight to 70, and you did a refresh. Okay? So hopefully you'll get a different value of BMI. But before you did that, you did these two extra steps. What do you think these two extra steps are doing? This is pausing, so that the human can actually consume and see the value. Okay? And thread support is a class that Object Editor provides. And you know, I haven't told you the package in which it exists, but you guys know how to go and find out the package of a class if you don't know it? So whenever you put a name that it doesn't know about, it'll give you a little X box saying there's an error. Whenever you have an error, it has a guess as to how to correct the error. So you just click on it, click on the error, and it'll give you an option of, you know, wait, and you just take the option, it'll correct. Okay? So this is what it's doing. That's the main thing. And what do you think the select might be doing? It might go and somehow, because as a human being, you don't know which is changing. You have to go notice. So it goes and just colors the weight in a certain way. It's as if the user selected. Okay? So if you want to actually create your test cases this way, okay, there's nothing difficult here. Okay, but this is just a way of demoing your object. Okay?
Could you set how you have 5,000 seconds or something? Could you set that to be a variable?
You know, so I was bad here. Right? I put 5,000, 5,000, 5,000 in each time, and all of the 5,000 should be the same value, right? So I should really put that 5,000 into a variable, and rather than a variable, what would I put it in? A named constant. And I'd give it a name, delay.
What if you wanted it to be different based on what was happening next?
Yes, you could put any value there. That value can be computed based on a random number, based on whatever. But here I'm saying, you know, the TA can consume things this 5,000 means 5 seconds. Okay? So, that's I think it, yeah. Okay? So, that's what I mean, but you can put any value.
So what does the select do? Like put out focus and then...
So it'll color it. It'll color this value green, and it'll go from there to there. So there's a video here. Okay, so thread support makes the program wait for a specified number of milliseconds. So that's why that 5,000 was 5 seconds. And there's a video here that you know, I've got a YouTube link to, and you guys can play to see what happens. Okay. So you see now interaction between object editor and your program. Okay. And this is very typical. When you write programs, you don't write programs alone. You write programs with other people. And you have to know how their programs interact with your program. Okay. So you have to understand their rules and follow their rules. And so by using object editor, you get many things. You get, one of the things you get is a way to interact with, to follow a certain contract. Okay? So the object editor says, if you do this, I'll do this. So when you program, you have to follow to these constraints. And when you use a programming language, something similar also happens, that you have to follow the constraints of the language. And here you have another class, okay, that you're interacting with. Okay? So we understood our properties, how they're handled by object editor, how they're displayed, how they're refreshed. And let's just try to understand properties a little bit more in depth. Okay, so we said height, weight, and BMI are 3 properties. We said height and weight are editable, and BMI is read-only. Is there any other way you can classify these properties and distinguish between them? So BMI is different from height and weight because it's read-only. Is BMI different from the other 2 properties in some other way also? It's not stored. Excellent. Okay? And it doesn't have to be stored because it is read-only and because it is, it gives you different values. So it's not a constant. It's a dependent property. It's a function. Okay? So the height and weight are independent properties. The BMI is dependent. That's why we call this a spreadsheet. We see this concept in spreadsheets. Okay, this is just a custom spreadsheet we built. And the other 2 properties are stored, and in this case, this property is computed. Okay? Okay. To further understand properties in depth, tell me what are the properties of this object? How tall? I changed the name of the variable from height to HGHT. Okay? And I changed my getter and setter method to say get how tall and set how tall. So I made 2 changes. And just to emphasize that properties are not variables, they couldn't be, otherwise we couldn't have unstored properties. Okay? The property really is how tall. Now I'm not advocating this is the way you should program. Okay, firstly, spell it. You guys are good typists. Okay, so even though you might use IM, and just spell it out with height rather than HGHT. And once you've got a long spelling of a variable, Eclipse has shortcuts that it'll allow you to just fill the names for you. Okay, so nothing wrong with having long names, and lots of good with having long names. And typically the property name, if it's a property is stored, then make the property and variable the same. Okay, it just causes less confusion. But in case you did it, this is the property is how tall. Okay. Okay, tell me the properties here. That's the first. This is the second class we saw. Doesn't have. Not every object has properties. Okay, and if you display it, you see nothing in the main window because it has no properties. Now, there may be cases where you intend your object to have properties. You thought you followed the conventions, but you see no properties in object editor, and you said, damn object editor, what's it doing? Right? So, how could you, but sometimes you really don't intend there to be any properties. So it'll be nice if object editor gives you some messages saying, hey, I think this is what you intend to do, but you're not quite doing it. Could that help? It'll help you come up, really master the bean conventions. Okay? So it'll be nice if you tell object editor things about your program. And this is how you could do it. And there's some magic words here that you haven't seen before, but based on your knowledge of English, what do you think I'm saying there? So I guess I haven't used the word pattern before. When you use the bean conventions, you're following a certain pattern of naming things. Okay? The bean pattern. And here you're saying you're following. Okay? So object editor, don't try to do anything. Don't try to look for anything interesting. Okay? Don't try to give me error messages. I know what I'm doing. Okay? And it's almost like a comment, right? So what's the difference between this and a comment?
comments aren't read by the compiler?
They are not read, but they're just ignored by the compiler. Okay. Somebody else also had something? Okay. Okay. And so this is a typed comment, and it's an annotation. Okay. It's not a comment, but it behaves like it's better than a comment. It tells a human being what's happening. The human being knows no properties are going to be defined, but it's really a type. It's really a class in the system. So structure pattern is really a class which is in this package. That's why you have to import it. And you just, the @ sign says this is a annotation class, and when you call this, a certain method in that class is called, and this is an argument to that method. Okay, it's a little complicated, but think of this as a type comment, and they have to do with, because it's typed and types are defined as classes, these type things have to be imported, and the @ sign, and have you guys seen the @ sign before? @param, override. These are the annotations defined by Java. This is the annotation defined by object editor, or by me. Okay, used by object editor. So you can define your own annotations. Okay, and this is just a named constant here. Structure pattern names.no pattern is just a named constant. Here I'm being good. I actually used a named constant. Okay, and I'm going to encourage you guys to have lots of annotations, because it just that's a much nicer way of commenting than comments, because it's something that a tool could use, and it gives you more structure. Okay. So in general, structure pattern name before class assumes that the class is following the pattern, and the pattern name is within angle brackets. Sorry, and those angle brackets meant that it's really a placeholder. Okay. And so if you really are going to follow the bean pattern, then you go and do something like this. Okay, and you say, look, I'm following the bean pattern, and so the human being knows you're using the bean pattern. Object editor knows that it should give an error message if you define no properties at all. Can you think of this having another benefit having to do with efficiency? Yeah. Marco?
It can help objects editor look through the code, and it's knowing that it will run faster than
what to expect. Okay, it goes to the code and says, is the code following no pattern? Is it following the bean pattern? Is it following something called the list pattern? So it has to do a lot of searching. Here it says, oh, bean pattern. Let me just verify whether it's a bean pattern. I don't have to go and search and figure out what pattern it is. Okay? So it's documentation and efficiency. OE does not need to look for the pattern. Okay, so to do your assignment, I think I asked you in assignment 3 to go and put these annotations. And so they're not hard to use. Okay, and if you have any difficulty, if it takes more than 1 minute, please send a message to Piazza. Okay, and you can't find the import class. This is supposed to be a no-brainer. Okay, and you can give error warnings. Okay, to further understand these conventions and get us in. What have I done here? I've got my get height. I've got my get weight. My set, I replace set weight and set height with a set method, single set method that takes weight and height as arguments. And I changed the get BMI to BMI left paren, right paren. Okay. It's not very bad programming. Okay. And what do I see there in the user interface? So firstly, there's no BMI there because there's no get BMI. Okay. What effect did we have of changing the set method to replace the 2 set methods with the 1 single set method? You can't edit it. You see them grayed out. Okay, because it says I don't recognize the setter method. Sure, you think this is setter, but the setter has to be for a unique property, and this is 2 properties. This is too confusing for me. Okay, so beware. This is something you might do naturally. Okay, but it doesn't follow the convention, so you'll get into trouble. Now, do you think object editor will give you any errors here? You didn't give it an annotation. Even if you said it follows the bean pattern, would it give you any error? You know, if you had said, I'm following the bean pattern, and we saw how to do that in the last slide. Should it give an error at this point? You have some properties. You said you're following the bean pattern. It found two properties. They were read-only. So again, if you were to design object editor, what could you, and you can't figure out why this is not, you can't figure out why these height and weight are not editable, and you can't figure out why BMI is not shown. So what could you tell, how could object editor help if you just told it something?
If we told object editor that it always has to give output.
So output, the word output is used in many ways. One is that you print something on the console. That's what output is.
Okay.
The other is a function returns a value. Some people think that's output, that's not output. Okay? A property is read-only. Or read-only. Or it's got a getter. That means it's displayed by object editor, but that's not output. It just means you define a function that's used in a specific way by a tool. So if you told object editor something, and I think you're on the right line, you just need to use the right words. If you told object editor, Marco?
So if you annotate right before focus double BMI, and you tell object editor that it's supposed to, I don't know the right word here, return or display, whatever, then it will hold you to it.
So somehow you want to tell it right here, this is the BMI property. Right? That's one way to do it. That's good. What else could you tell it? But, that's one way. So somehow tell object editor that there's a BMI property. Okay, we are not going to change object editor's behavior. It's still going to expect get BMI. So you have to tell object editor, look, I have a BMI property. Okay? You tell me why there's no BMI property here. And similarly, you could go and say, look, I expect to have an editable height and weight property. You tell me why I don't have it. Okay? So can system catch these errors? There's many ways to tell object editor things. Here I'm showing that it says, look, these are my properties, height, weight, and BMI. If they're missing, tell me why. And here are my editable properties, height and weight. And if these are not editable for some reason, tell me why. Tell me what I should do to fix that. Okay? And here you get a little message explaining, please define a setter with this header, please define a getter with this header. Okay, so if you really have issues with this, so this is not really improving the efficiency. Okay, and if somebody who really understands the conventions, it's not really helping them. This is helping you. So I'm not going to insist that you put this annotation. I'm going to insist that you put the pattern annotation so that things are more efficient and it's better documentation. But the other two properties, if things aren't working, you can use these. Okay, I've been told by other people that we really have trouble with the naming convention. So I put this between last time I taught this course and this time, and I'll see whether this is useful for you or not. Marco?
One of the things too is your property names may change if you're doing programs.
So
that can be inefficient. Whereas if you could just annotate right before you do a property and say, hey, it should be this.
Right.
You can change the property name to whatever.
So the problem, one of the reasons why I'm not going to insist on this is because what you change the name of the methods, you have to change here also. And some languages like C# have properties built into the language. Okay? So it's much ado about nothing in those languages here. It's just, it's just because Java's limitation. Okay? And what the mechanism you're talking about, where you're saying, treat this as a property, you still have to go and say what name you want to give it. So that name itself would change. Okay? So there's a way in Object Editor to go and change the patterns it's following. You can go and say, okay, obtain P is the get P. Okay? And you can define your own patterns, and that's the way to handle that situation. But it's just better to go and change your code. Okay? Now notice here that height is displayed before weight. Okay? And any idea why height is displayed before weight in all the examples we've seen so far? Alphabetical. Okay? First, all the editable properties, then all the read-only properties, and both these lists are sorted alphabetically. And if you really want to change the order, there's many ways to do it. One way would be to just go and name these properties in a different order. If you just say weight, height, and a lot of students come to me and say, we don't like the order in which object array displays. I say, it doesn't matter. It matters to us.
I'm curious why how you consider the only set height.
But, oh, was there a set height originally also?
Yeah.
Okay, that has to do with bean conventions, I believe. So this is something, I actually use the beanbox tool, and if they find, either I've got a mistake here, which I don't think, but if you go and add a set method, okay, I think that's what it gives me, or there's an error here. So try it out, guys. See what happens. But I believe I might have either deliberately put this because the beanbox did it. I used something called the introspector from Java, which did it, and it has this behavior. But I think because it caused so much confusion to students, I think I've done my own thing since then. So I think OEAL 20 probably doesn't have this problem. Okay? So 19 might have this problem, but 20 might not, because it was getting to be an issue. But you're right. This is ambiguous, but if you have a set like this and this, it gets a little confused, the introspector. Okay? But you're right, it shouldn't. And I think I might have fixed it in OEAL 20. Okay. Okay. Other questions?
Because the set height method doesn't enter for us.
Oh, sorry. That's the reason. There's many reasons it fails. That's right. Thank you. I didn't notice this because it's an integer. Okay. No, it has to be consistent.
Oh, okay.
You can't have setter method use this type and getter method use another. Okay. But there was another problem also with it, and I think it had to do with the fact. Well, anyway, let me not get into it, but I don't remember the problem. But I know it does get confused with certain setter methods. Okay. Okay. Let's understand, what we've been doing a little bit still. So we put these tracing methods there, system.out.println set weight call, and we said println new weight. Okay. And output is something that's simple, right? The very first program students are taught to write is the Hello World program. You print something. So how difficult could this print be? But there's some subtleties here. So what is the argument to println in the first statement? What type is it? String. What's the type to the other one? Double. So can you call a method with two different arguments? Do different argument types? Yes? How would it behave? Yeah. You can't call a method with two different types unless you're using something called using objects. Okay, but here we're not using. In one case we're using double here, so we can't quite do it. So there's actually two different methods with the same name. So the name is being overloaded. Okay. So this is string, this is double, two different operations with the same name. And what's really going on is that there are two print lines that you don't know about with the same name. Okay. And do we see this concept in English? Same word that is different meanings. Okay. Okay. So in one case we're using fly as a verb, and in the other case we're using it as a noun. Okay. Two different verbs. And we know what's going on here, right? Okay. So the context of actual parameters determines what method is being called, and the context of that word helps us determine. So just as in natural languages we use context, so we do so also in programming languages. Okay, here's a little bit more complicated thing. I'm calling set weight and new weight. That's we already dealt with. And now I'm saying println set weight called plus new weight. Do you see some other form of overloading here? Sorry?
Something like the very line and nothing's really
So what's the other form of overloading? Yeah.
So you're converting so for instance, like the last one, that starts out as a stream.
Yes.
And because your content, you're adding that, then it's going to convert whatever that is to add it into the stream.
So what is this plus? I mean, plus we know with inch. We know what inch plus is. We know what double plus is. So overloading occurs in natural languages. Overloading occurs in mathematics also. We use plus for ints and doubles. And if you know how that works, there's a different form of addition you use for integers and different for doubles. We just use the same symbol and say, let the context decide. Okay? And that is operator overloading. And we see operator overloading here also in Java. And there's really a plus method, if you think of that. It's just an operator. And there's one plus that says, and so what we've done is, firstly, we've said plus works for strings and strings. Okay? So if plus works for strings and strings, then plus really, what does it mean? We know in mathematics what sum of two doubles is. What's sum of two strings? Well, it's concatenation. Okay? And we've confused things even more here, because the left of the plus is a string, and the right is an int, which means the int has to, or double. Okay? And that double has to be converted to a string, and then they are concatenated. Okay? So this is something you do all the time, and this is what it really means. And we have plus. We have many different pluses, and here there's a plus we are using that takes two parameters, string and int, and the way it behaves is that it converts the second argument into a string, and then calls the plus with string and string. Okay. Okay. So context is good, except that it can be ambiguous at times. Okay. And what if I had two print lines? Both took string argument. Then when you said print line set weight call, would you know which one to call? Sorry? So the compiler says, you can't define a method twice with the same arguments twice. Okay? So they've got to, the arguments of parameter types have to differ in at least some way. It looks at the parameter types to decide which one to call, and they have to differ in some way. It doesn't look at the return type. Okay? That's just too hard. Okay? It's ambiguous actually. So it looks at the parameter types, it looks at the list of parameters, and the list of parameters types is identical in two methods. Then it won't allow you to define the second. It will say duplicate method. Do we have such problem in English that the context is ambiguous? No? Never faced it? So what does this mean? Fly is being used as a noun or a verb? So, I'm just learning English. I don't know what this means here, right? I'm confused. Anyway, so this is the classic example, actually. It's not my own. I wish it was. Okay? I learned this in like 6th grade, when I was studying English. So, okay. So you're defining two versions, and why is overloading useful? Okay, so why is overloading useful? You could have used different names, but because why not just name it differently? It's convenient. You don't have to think of new names. It's a similar function. The same is within double quotes. Okay. It's intuitively the same thing.
It makes it so we can copy things more easily. For instance, if you've got a super class and you're making a bunch of subclass, then you could have the same name for each group of things, and copy it and change the parameters.
So if you're copying and changing things, then then who knows what you're doing? Yeah. So at that point, who knows what you're doing. It's just the similar operations should be given the same name so that we know what the behavior is. Okay? Fewer names to choose. When you write programs, you think, oh, let me just get it working. That's half the battle. Choose the right names. That is tougher. And by the way, if you choose the right names, getting it working is easier. Because then you know what that variable is doing. Otherwise, you say variable I. You'll figure out what it means, but I think I need some int. Let's call it I. But if you say it is start of token, it's end of token, now you know what these variables are supposed to hold, and now you can write your program easily. I, J, oh yeah, J meant start, N, was it middle? Who knows? So choosing the names really, really helps you get your program working better. And it's difficult. Okay? Okay. So we saw that when an object is first created, this BMI spreadsheet is first created, it has this, BMI that's not a number, and it has height and weight that no human being ever has. Right? So it's this object is in an inconsistent state. I mean, that's just an illegal object. Right? And we were able to create this illegal object because Java allowed us to do it. And in fact, we don't know how to create this object to be always legal. Okay? So, how could I make sure that this doesn't happen? I could go and say new BMI spreadsheet, set the weight, set the height, and then tell object editor, please edit this object. So at least the user doesn't see any illegal value. Okay? But how could I make sure that the object never has illegal values? And some of you know how to do this. This is a feature. The feature you need to do this is required for for assignment 3, constructor. Okay. So I could just do something like this. New BMI spreadsheet, and this is what was being mentioned earlier, that can I just pass parameters while I'm constructing it? Okay. So I say new BMI spreadsheet. Typically, we never looked at the new in great depth, but when we instantiating an object, we said say new, give the class name. And then we had the left paren, right paren, and who knows why we were doing that. Okay? But now you can see why we said new left paren, right paren, because between the left paren, right paren, we can put parameters. Okay? And parameters are things that are associated with methods. So somehow when we go and say new class name, some method is being called, and these parameters are being passed to that method. And that's your constructor. Okay? And if you do that, and we don't know what the BMI spreadsheet is doing with these parameters, but whatever it's doing, make sure that you get initially this height, weight, and BMI. Okay? So let's see what it's doing. What's it doing? It just calls set height and set weight with the values. So now I put this little constructor here, okay, which is what? I've got which is a method. Because it's a method, it's got arguments. It's using these arguments to call set height and set weight with the initial weight and height. Okay? But it's a funny kind of method. What's funny about this method compared to these methods?
There's no return check.
So it has, this is public double, public void, and this is public name. So there's no return value. Anything else that is unique to it? The method name is the same as the class name. So if you were to say that, look, this method is returning some value, what would be the type of the value in your mind? The same class. So it's really, you can think of it as saying public, a BMI spreadsheet, a BMI spreadsheet. The first BMI spreadsheet says this is my type. The second one says this is my name. Okay? Well, we combine them both together. So that's a constructor. Constructor is a special method, and get height and set height are called by you explicitly. The constructor is being called by you. When you instantiate, you're saying, please create an instance of this object, and please call the constructor method in it after construction. So constructor is really an initializer, and it's saying initialize it. Okay? Questions?
Should you use set height and set weight, or can you just say this height equals
So there are three choices actually.
Okay.
You can say set height and set weight, or you can say this dot height equals initial height, or you can just say height equals initial height. Okay. So this dot height is just long-winded, right? So let's forget about that. Okay. That is useful if my parameter is called height also. Okay. Then you have to disambiguate. So anybody have an opinion? Should we call a setter method to change a variable, or should we just use assignment directly?
Well, if you do a setter, you'll have to anyway know what's going on.
Object editor has to call a setter. Okay? But setter doesn't have to be called by object editor always. And object editor doesn't even know you did this. You did it in your program. You didn't go through object editor. Remember, that's why the refresh didn't happen earlier? So it didn't go through object editor. If you went through object editor, you have to call setter, in which case it has to be a public method, yes. But here you're within your class, internally doing this. Yeah.
There may be times you want to do XOR where you access the value. You don't want to store the previous value for like undo. You can never call a setter and you can get that work done.
So your setter might do more than what the name seems to indicate. It might do some bookkeeping things. And the question is, do you want that bookkeeping to happen in initialization or not? If you want it to happen, please call the setter. If you don't want it to happen for some reason, then please use this type. Also for debugging purposes, this is more convenient. Okay? Often you don't know why values that you see are what they are. So you want to know where they got changed. Okay? If you want to trace the value of a variable, you can actually go to Eclipse and click on the variable declaration, and you can trace it. Every time the variable is changed or read, your program will stop and it will tell you can read the value. But every time it doesn't distinguish between being read and being written. And I want to know when it's being written. I don't want to know when it's being read. So if I did all my changes through my setter, then I would put a breakpoint on my setter and just see where the variable is changing. So from that point of view also, a setter is good. Okay? So I'm glad you asked the question because I was answering it here. So calling setter method instead of modifying variable directly makes debugging easier. Okay? And I guess I didn't mention the other point, which is that what if you're doing additional steps? In that case, it depends whether you want the steps done in initialization. Okay. So we see here that the constructor name must be the name of the class. Constructor name is also the type of the object returned. And every class has a constructor. When you said new BMI spreadsheet, even when you didn't put a constructor in it, you had to go and put left paren, right paren. You had to say, I'm passing you no arguments, no parameters. But there is no constructor here. So what does it mean to call a constructor when a constructor doesn't even exist? So you did not put a constructor in, but a constructor exists. So that must mean that the constructor is not in the source code, so it must exist in your compiled or object code, and that is the default constructor. That's something object editor puts in, Java puts in, okay? And it puts in if you have no constructor, and it does nothing.
Okay, if you write a constructor, does that override the default constructor?
So if you write your own constructor with no parameters, if you write a constructor, then that default constructor is not put. It says, you know what you're doing, and so you can't instantiate the object with no parameters. Okay? If you have a constructor with parameters. So yes, you override. So this is the constructor created by Java. Does nothing. Okay? If you study inheritance, if you know inheritance, it's not that it doesn't do anything. It calls a superclass constructor. So this is not a useless thing. You don't see that because that also is put by default. Okay? So this is really saying, please call my superclass constructor, and even though you don't put a superclass here, that's also put by default. Okay? There is a class called object, that's the superclass of everything. So I'm just going ahead a little bit to say that it's not as if it's doing nothing, but syntactically, there's nothing between the curly braces. But there's a lot of stuff going on underneath. Okay? So this is called a null constructor. Insert in object code, not in source code. So you never see it. It's not as though it puts it in your code. It's just put in the compiled code. So a class can have multiple constructors. I can put a constructor with no parameters. I can put a constructor with 2 parameters. And does that sound all reasonable? Because we know there's overloading. Because we know constructors are methods. Methods can be overloaded. When you instantiate the object, you may instantiate it with no parameters, or you may instantiate it with 2 parameters. Okay? So it's up to you. We are flexible. Okay?
So if I wanted to
Yeah.
the overlay, then could I call it to structure? That's a bit different.
You can't, when the object is called, you don't call it, right?
Right.
Since you don't call it, you have no choice. When you construct, when you say new, at that point, whichever constructor was implied by your new is called. Okay? But this is what you could do for creating 2 different instances. You could use 2 different constructors. So here you said new BMI spreadsheet. This is allowed because I have a null constructor there. If I did not have the null constructor, this would not be allowed. Okay? If I did not have a null constructor and I had another constructor, if I had no constructor, this would be allowed. Okay? And I go and say set weight, set height, print line, and I could have done this also. Okay? And I have flexibility. Okay. So we've seen that I could have, if you, that we didn't really need the constructor as long as we were disciplined. Right after we constructed the object, if we went and initialized using setters, we could have done without constructors. Okay, like I said, some languages didn't have constructors. So are there situations where you really, really need constructors to make sure that the object has valid state? What comes?
If you have an object that has read-only variables, you use constructor to set the values, and then there is no.
Very good. Okay, if you have read-only variables, then you have no setter. So how do you initialize those variables? You won't be able to initialize them outside. So you have to go and pass those values through constructors. Okay? So some part of the exported state, example height, sorry, there's a typo there, may be read-only. Okay, so I might be creating a BMI spreadsheet just for myself, okay, and my height will not be changing, so I just go and don't even export it. I export it as read-only property, but I don't have a setter method for it, so then I must pass the height when constructing the object. Have you all ever seen objects with only read-only state? No no writable state at all? In your previous classes, if you've done Java, maybe even Python? It's a very popular type. It's a type you've already used in your last 2 assignments. So what object type have you used in your last 2 assignments? What primitive types have you used? Int? What object type have you used? String. That's an object type. Can you change a string? What does that even mean? Quite. But objects that cannot be changed. Have you guys heard this term? Immutable objects? Okay, these are objects that you can't just change. No setters at all. Okay, and string is an example of that. If I've said string s is assigned new string hello, I can't go and change the string object later and make it goodbye. Okay. String is immutable. An immutable object cannot be changed after initialization, and you cannot create immutable objects without constructors. Okay, now please remember this, because in your next assignment you're going to have to create immutable objects. You're going to say, well, how do I go and initialize a state? And you're going to be baffled. And then when somebody says, just use the constructor, you say, aha. But somehow it doesn't come inherent. So So an immutable object with state must have one or more programmer-defined constructors. So what's this then? This is legal in Java. Am I not changing the string? You're concatenating the string. So am I just adding to hello world? You're creating a new string and adding to that world and returning a pointer. This is a very expensive operation, by the way, because you take the hello, make a copy of that in memory, and to that copy you add world and return a pointer to that new area. It's very easy to write. From a programming point of view, you say S, S is S plus world, but actually you're creating an entirely new string object. Okay, the variable S is changing, but the string hello is not changing. We saw in memory that there's a variable. The variable has got an address stored in it, and there's the object. Okay, so when you said BMI spreadsheet.set height, the variable BMI spreadsheet did not change, but the object BMI spreadsheet changed, and here we are changing the variable. So assigns to S a new string object. Does not change the original string. So why do you think Java has immutable strings? Yes, say it's a root. Or you can say maybe they were thinking deeply. But before Java, people had mutable strings. The answer is kind of subtle, so I'm not surprised you're not getting it, but maybe. You give, if you say something is immutable, you there's more guarantees about that object, right? So maybe it'll help. Firstly, it's easy to implement. I mean, I've already allocated a string object somewhere, and you want me to insert something in there. That object under that object is another object. I mean, what do I do? Where do I move it in memory? Maybe if I move it in memory, then what about the references to it? It becomes very tricky. Okay? It's possible to do things like that, but it becomes tricky. Okay? How many of you have used hash tables in your previous class? 2 people? Okay. You won't be using hash tables in this class either. But there are things called hash tables, hash map, okay, or map interface. And as it turns out, those maps have keys in them, and you associate keys with values. And if those keys are typically strings, and if those keys ever happen to be mutable, all kinds of bad things happen. And when I've used those keys, mutable objects as keys, I've been burned many, many, many times. Okay? And here's another reason. Say I say string S1 is hello world, string S2 is hello world. Now I go and say print line S1 equals S2. Okay? 2 objects are equal with the equals as long as they have the same address in them. 2 variables are equal as long as they have the same address in them. So do S1 and S2 point to the same hello world or 2 different hello worlds in memory? What do you guys think? 2 different? Did you guys learn this in class, or do you just guess it? You learned that in class? Anybody else learn that in class? That's how Java used to be. Okay, that's not how Java is today. And I've always been mad about the Java implementation before, because this was a beautiful example to show why you should have immutable objects, but Java didn't seem to exploit that. Java would allocate one string hello world there, another string hello world, another place, but why? Hello world is not going to change. Okay, so why not just have both hello worlds be allocated in one area? So today when I ran this program, this one printed true. They are actually pointing to the same area. So finally, they're exploiting the full usefulness of immutable objects. Okay, and you can do that because strings are immutable. If you could change hello world, then you can't afford to have both variables point to the same thing. Okay?
Is that in the newest version? You don't need the dot equals?
No, that's different. Dot equals is different. Okay? If I go and say new string hello world and new string hello world, or if I go and read hello world from the user input, where you don't know what was read, indeed you're going to have different objects, different areas in memory for that. It's only when you use that in the program within quotes. At compile time, this is a compile time thing. At compile time, Java knows that you type hello world here, you type hello world here, it can just allocate one area. Just as when you go and say, int I is assigned the value 5, and int I is assigned the value 5 again, 5 has to be put somewhere in memory and then copied into I. And they just put one instance of 5 there. There's something called a literal pool. When a compiler says it goes and says, oh, 5 doesn't have to be repeated in memory, so I'll just put it once in memory and assign that value to I each time I is assigned 5. Okay, that's what's going on here. So no, if I said new string hello world, you'll get two different objects. Yeah.
So what is the difference between just assigning the string, a string in quotes, and actually using the string constructor? Like saying string S1.
So when you said new string hello world, you're telling Java, I don't care about efficiency. I just want these to be at different areas. Please construct a new object. So it'll go and take hello world, put a pointer to it in that new string object. Okay, you get two different string objects. So if I said new string, this will return false. Okay, that's when equals will return one thing and equals will return something else. Okay. So allows literals only, the things that are string constants, to share memory location. Okay, not objects to share memory, but just literals. Literals are 5, string word, hello world, and so on. Okay, if you want mutable string. So why do you think Java has immutable strings? Yes, say it's a root. Or you can say maybe they were thinking deeply. But before Java, people had mutable strings. The answer is kind of subtle, so I'm not surprised you're not getting it, but maybe. You give, if you say something is immutable, there's more guarantees about that object, right? So maybe it'll help. Firstly, it's easy to implement. I mean, I've already allocated a string object somewhere, and you want me to insert something in there. That object under that object is another object. I mean, what do I do? Where do I move it in memory? Maybe if I move it in memory, then what about the references to it? It becomes very tricky. Okay? It's possible to do things like that, but it becomes tricky. Okay? How many of you have used hash tables in your previous class? 2 people? Okay. You won't be using hash tables in this class either. But there are things called hash tables, hash map, okay, or map interface. And as it turns out, those maps have keys in them, and you associate keys with values. And if those keys are typically strings, and if those keys ever happen to be mutable, all kinds of bad things happen. And when I've used those keys, mutable objects as keys, I've been burned many, many, many times. Okay? And here's another reason. Say I say string S1 is hello world, string S2 is hello world. Now I go and say print line S1 equals S2. Okay? 2 objects are equal with the equals as long as they have the same address in them. 2 variables are equal as long as they have the same address in them. So do S1 and S2 point to the same hello world or 2 different hello worlds in memory? What do you guys think? 2 different? Did you guys learn this in class, or do you just guess it? You learned that in class? Anybody else learn that in class? That's how Java used to be. Okay, that's not how Java is today. And I've always been mad about the Java implementation before, because this was a beautiful example to show why you should have immutable objects, but Java didn't seem to exploit that. Java would allocate one string hello world there, another string hello world, another place, but why? Hello world is not going to change. Okay, so why not just have both hello worlds be allocated in one area? So today when I ran this program, this one printed true. They are actually pointing to the same area. So finally, they're exploiting the full usefulness of immutable objects. Okay, and you can do that because strings are immutable. If you could change hello world, then you can't afford to have both variables point to the same thing. Okay.
Is that in the rules version? You don't need the dot equals?
No, that's different. Dot equals is different. Okay. If I go and say new string hello world and new string hello world, or if I go and read hello world from the user input, where you don't know what was read, indeed you're going to have different objects, different areas in memory for that. It's only when you use that in the program within quotes. At compile time, this is a compile time thing. At compile time, Java knows that you type hello world here, you type hello world here, it can just allocate one area. Just as when you go and say int I is assigned the value 5, and int I is assigned the value 5 again, 5 has to be put somewhere in memory and then copied into I. And they just put one instance of 5 there. There's something called a literal pool. When a compiler says it goes and says, oh, 5 doesn't have to be repeated in memory, so I'll just put it once in memory and assign that value to I each time I is assigned 5. Okay, that's what's going on here. So no, if I said new string hello world, you'll get two different objects. Yeah.
So what is the difference between just assigning the string, a string in quotes, and actually using the string constructor? Like saying string S1.
So when you said new string hello world, you're telling Java, I don't care about efficiency. I just want these to be at different areas. Please construct a new object. So it will go and take hello world, put a pointer to it in that new string object. Okay, you get two different string objects. So if I said new string, this will return false. Okay, that's when equals will return one thing and equals will return something else. Okay. So allows literals only, the things that are string constants, to share memory location. Okay, not objects to share memory, but just literals. Literals are 5, string word, hello world, and so on. Okay, if you want mutable string, something called string buffer, and here you said S is assigned S plus world. Here you say string buffer S is assigned new string buffer hello. Then you can say S dot append world. Okay, if you see in array lists or vectors, these are the kind of operations you can do. These are objects that can grow in memory, and they deal with that somehow. Okay, they just allocate a lot of memory to it in the beginning, and if it goes out, they just go and allocate some other portion of the memory, and it's just a little bit more complicated implementation. Okay, here we're not reassigning the string buffer. Okay, I called it, I guess, S. I meant to call it SB. So there's a little bit of a mistake here. Okay. So this should be really SB rather than S. So reassigning a new object is less efficient because you're constructing the whole, you're making. Okay. Now, I've tied getters and setters to object editor. Okay, it's a nice visualization of this concept, and you really see how the conventions are being used in an interactive tool. But you don't have to use object editor to manipulate properties. Here I create a BMI spreadsheet. I go and set its weight, set its height, then I go and compute the value back, and I print it out. Okay, so if I wanted to compute my BMI, I needn't have gone and displayed the BMI object on the screen and changed it interactively. I could have just written this program. The problem here, of course, is if I want to try different values of weight, I have to run the program again and again, or take a read input or something more complicated. Here I did it only for one example. So let's go back to the code we had. I'm calling some variables primitive variables, some values primitive values, some variables object variables, some values object values. So clearly a BMI spreadsheet is an object. And we've been calling it an object, so it is an object. So the variable that stores an instance of it must also be an object variable. Okay? And the BMI spreadsheet instance is a value that you assign to a variable of that is an object variable. Okay? So what are primitive values in variables? No, instance variables are variables inside an object. But yeah, often the instance variables are primitive. But the instance variables of an object may not be primitive. So a variable could be primitive or object. And I'm saying that somehow the double is primitive. Its type is primitive. So what kind of types are primitive? And how do you know whether it is primitive or not primitive? They're all predefined, so they're bold. They're lowercase. Sorry? The non-primitive ones are classes. If you know what a class, and they begin with uppercase. And to get a value that is object value, you have to always say new something. You don't say new for primitive. You don't instantiate something. You just assign it 1.5, 1.7. Okay? Now this is just an ints and doubles could be objects. Okay? In Simula 67, which I told you was the first object-oriented language, they made a distinction between classes and non-classes. Smalltalk said everything is a class. There's no distinction between an object and a primitive. C++, which was sort of taking C, which was not, didn't care too much about elegance, said, we're going to make a distinction again. And Java, which seemed to be going towards elegance, said, you know what, we're going to go back, we're going to keep the C++ approach and make a distinction. And the answer why they did it that way has to do with sort of extra things they added over Smalltalk. And if they made everything an object, it would be very inefficient. So there is this distinction. And this causes all kinds of confusion to programmers. Every time you sort of have, you make a rule that doesn't make logical sense, it's confusing, right? So you learn the English language, and pronunciation is a nightmare for anybody who didn't grow up with that. Because it's not a phonetic language. It's, you always see a kid making mistakes. And same thing here. People get very confused because they create a model of programming based on primitive variables, and suddenly it doesn't work for object variables. And for those of you who've used primitive variables and object variables, what are some of the confusions that have been caused? Have you had to, you have to say, oh my God, this is an object. I didn't, yeah. It's very interesting. When I learned programming, we used to talk about by value and by reference. That was such a fun topic. There was by value, by reference, by name. And I'm amazed somebody your age knows the difference between value and by reference. Knows at least these terms. But, you guys don't see languages that pass parameters by reference. Not even Java does that, actually. Okay? So, it's getting to the difference, but it's not. Nothing is being passed by reference actually. It's the way they're stored actually is what's the difference. It's very close. Anybody else want to?
Yeah, primitive variables are stored in the stack, and then objects are stored in the heap. Right?
So objects are definitely stored in an area of memory called the heap. But primitive variables can also be stored in the heap as part of an object variable. Okay? So that's also a good thing. But by reference, so when you say by reference, what is it? What's the definition? Because we're getting close to that. It has to do with.
So that means that you have or
So where did you learn this? In which language? Did you learn Pascal or?
I studied with Jay.
Okay, there's still languages that hello. So by the way, okay, anybody else somebody else was raising their hand?
Right, for object variable, the object stuff.
So object variables store addresses to the values, and primitive variables don't store addresses, they're just allocated. So when you send, and they're both passed by value. When you pass an object by value, you just make a copy of the address and send it. And when you go and pass by, and so it's by value, but what you're passing is an address. Okay? So a program like Pascal, language like Pascal, it had reference and value. You would take the same parameter, pass it by reference or by value. C had all by value, but it allowed addresses to be sent. So I think I might have some slides on this to make it all clear. Well, let me first show you some sort of, from a programming point of view, how it makes a difference. Now, I said double compute BMI, but I didn't assign to the variable any value. I have BMI spreadsheet. I didn't assign to that BMI spreadsheet any value. So I have uninitialized primitive variable, uninitialized object variable. Now, can you use one model to describe what's going to happen in both cases, or there's going to be something different in both cases? In the two cases. One is going to be an issue and one is not going to be an issue. You won't at least get a runtime error. So you'll get a runtime error, but you won't get that with the computed BMI? That's true. What kind of what kind of runtime error are you going to get? Null pointer. So we know, that somehow they behave differently. And again, I've used the word pointer. You get a null pointer. There must be some kind of pointer in one case. So when you don't assign a variable any value, object editor does something default. It says, okay, you didn't assign something, I'll assign something. You have to have a variable have a value. Okay, I mean, variable is just a slot in memory. It's got to have some bits there. You can't say it's empty. It's going to have some bits. So what's going to be the default? If you don't assign to computed BMI a value, it's going to have what value? 0. If you don't assign to a BMI spreadsheet any value, what's going to be stored in the slot? It's going to be the 0 value, all 0, which will be interpreted as null. So this is going to be 0, 0, legal double values. And the nice thing here is that's a legal double value. What you've got in the variable is allowed by the type of the variable. In this case, BMI spreadsheet is going to have a slot there, which has a pointer to the height and weight. That's what is expected to the object. But that object doesn't exist. So what you're saying is it has, the object editor will sort of put all zeros here, and all zeros here mean for an object it's a null pointer. It's not pointing anywhere. It's like you have a professor assigned, but there's a name, but there's no real person coming in. Okay? It's just there, a placeholder. So whatever you can do with doubles, you can do on 0.0. What can you do with BMI spreadsheet? You can say get weight, get height. You can't do that with null. Null is not a legal BMI spreadsheet. It's an illegal value. So if you don't assign it a default value, you have something illegal. When you do something illegal, the police catches you, right? So the compiler at runtime will say, sorry, you did something wrong. In one case you get caught, the other case you don't get caught because you get an illegal value. So if you say get BMI, you'll say null pointer exception, saying, hey, there is no object, there's no get BMI to be called, so you get a null pointer exception. And what's an exception? We'll look at that in depth later, but it's an unexpected event, as the name says. Okay? And if you don't do anything, the method that's guilty will be terminated and exception reported, which is what you'll get. Okay, let's start. For those of you still talking, we are about to start. Can I have you look this side? Okay. Is there something you'd like to share with the whole class? Something you want to share with the whole class? Huh? You're still talking. I just mentioned that it won't start. Okay. You should have all got your first assignment back. A couple of you have complained about the way it was graded, and that's fine. So I want to encourage more people to complain if you have complaints. You know, when I said, hey, when you send mail, you know, expect us to be reasonable. Okay, so don't go and ask us about details that, you know, shouldn't matter from the learning point of view. And before the assignment is due, you know, you get a rubric, so you get to know what points you'll, what points will be taken out for what feature, and so that's kind of cast in stone at that point, unless, you know, if you want to debate at that point. If you want to debate between that and assignment time, you can, but you might as well do that stuff. Okay? But when something gets taken out and you get partial credit, that's where some judgment call is required. Okay, so if you did one aspect of that rubric item and not another aspect, maybe you should get more points than you actually did, which is what a couple of complaints were about. And maybe you maybe you lost points with things that were not in the rubric and that you didn't think were fair. So go ahead and do that, you know, and we'll make the judgment call. There are 4 people grading this, and different people might be making different judgment calls there, and they may be making different judgment calls from what I would make. Okay, I don't grade your assignments, but I write them, so I have a little better idea of what I want to get from you guys on that assignment. So, like I said, a couple of people complained, and they both are getting more points. And I don't want this to be, you know, the squeaky wheel gets more attention. So, again, please, you know, don't complain for very little. You know, if a couple of points are not going to make much of a difference in your assignments. Okay, because there's a lot of assignments going on. But if it's something substantial and you think it's unfair, let us know, and then, you know, that's something that will go to the next time I teach also, because I give similar constructed assignments, and you guys who've done the work sometimes have a better idea than even I might, because you know, it's been a while since I learned programming, so I have to put myself in your shoes, but it's been a while. Okay, so go ahead and another thing is that, as one student pointed out, that your second assignment was due before your first assignment grades were returned. And you shouldn't be penalized for the same thing twice. So, you know, that's what one student said, and that's fair. So go ahead and point that out too, if that happens. Okay, it might have to do with style issues. So, you know, if there's some style issue that you weren't aware of, you can let us know. Okay, any questions on that? Questions on the current assignment? Please never send mail to me, never send come to me. Just send mail to 401 help. Sure. I mean, let them know first. They're not your enemy, you know, they can make a mistake too. If you've talked to the TAs and you don't find the answer, and I see those messages. So it's as if I don't see them. So always send mail because I often ignore those emails. I say, okay, so, you know, the next time there'll be a TA office hour, they'll take care of it. And I have a lot, you know, like everybody else, I get lots of mail, and some of it is junk. So, you know, it's very easy to pass over email. So if you send mail to anyone individually, you don't get response back, that's why you didn't get a response. Okay, so I'm on that list. Okay. Other things? Okay. And again, even if you got a lot of points taken out, but you got the basic scanning going, and you're trying to decide whether you'll be able to do this class well or not, you will. Okay, so as long as you got those tokens out, you're able to separate numbers from words, you're doing fine. Just disregard your brain. Okay, I mean, you'll do fine for the rest of the semester. Okay, just some teething problems that you can overcome. Okay, so don't get discouraged if you didn't quite get a very high grade. You will eventually. Okay. Other things? Okay. I put this example last time to give you an idea of what's happening in memory. And, you know, when you start talking about what's going on internally, you don't know how far to go. I mean, I could tell you how exactly the compiler works, and that will take me a couple of semesters. So I gave you some knowledge, but not enough. And then some of you started using words like heap and stack. And others probably felt very inadequate at that point because you'd never heard that term. So I've gone and extended the example, giving you a little bit more details. And I think that will at least let you understand if we ever use the term heap and stack again, what exactly we mean. We've talked about stack before, but not quite heap. So here's some code. Okay. You've got a BMI spreadsheet 1, which is assigned in the new BMI spreadsheet. A BMI spreadsheet 2, which is assigned another BMI spreadsheet. Then BMI spreadsheet 1, we call the sec height method in it. And then BMI spreadsheet 2, we assign to that BMI spreadsheet 1. So, you know, what exactly is going on here when we do this? So when we enter this code appears in some method. Okay? That method has some formal parameters, and it has some local variables, some internal variables. So we don't see the local parameters here, some formal parameters here, but we see the local variables, BMI spreadsheet 1 and BMI spreadsheet 2. So these two variables need to be in memory. Okay, we need space for them in memory. And that space comes from the stack. Okay, so local variables, whether they're formal parameters or whether they're internal variables, they're allocated from an area of, the space has to be created when the program is running. Okay? And there are two places that space gets allocated from, and why these two places are different is not very important, except that basically they're two different pools. You know, memory can get full, so they try to go and separate the memory into two parts. Okay? One is the stack, in which these variables get allocated. Okay? And initially, we haven't executed any code here. These variables are just totally uninitialized, so we see the null value there. Okay, we talked about the null value last time. That's basically saying it's really all zeros here. Okay, when you don't have anything assigned in memory, it's all zeros. How you interpret the zeros depends on what the slot is. If it's an int, it is the int 0. If it's a double, it's the double 0. And if it's just a variable whose type is object, class, it's just interpreted as a null pointer, null address. Okay, it's an address, and we'll see why exactly it's an address. So now I'm going to execute the statement where the arrow is. And there's two parts to that statement. There's the variable assignment. And before I can assign the variable, I've got to go and execute this new BMI spreadsheet expression. It's like 5 plus 2. This is an expression also, but it's a new BMI spreadsheet. It's a funny kind of expression, not something you see in mathematics. So let's see what's going on here. So okay, this is pretty much saying a stack is an area at the bottom of memory where slots for local variables get allocated. Okay, and stack always goes upwards. And heap is an area at the top, and heap goes downwards. So this is basically what I just said. And let's get this out now. So now I go and execute new BMI spreadsheet. So I'm saying I want a new object, I want a new car. Whatever. You know, that's the same analogy we used. So we produce a new object. That object requires some space in memory. And this is where it gets allocated from. So we had to allocate the stack, the procedure variable, okay, dynamically. That came from the stack. The objects come from an area called heap. Okay? So, but the main point is it gets allocated, the area gets allocated dynamically as the program is executed. And what should happen now when BMI spreadsheet 1 is assigned a new BMI spreadsheet? Firstly, let's look at this object. Let's look at this area. This area has a slot for height and weight. We know BMI spreadsheet has two variables called height and weight. They need space. So these two variables are just allocated space in contiguous slots. Okay? So together they define the objects. Now when I go and make an assignment of BMI spreadsheet 1, assignment to BMI spreadsheet 1 of this object, what should happen at that point? Should I copy that whole area over here? Yeah. So it will be assigned to the address of the object. And what's the address of the object? Object has got two variables, height and weight. So what do you think the address will be? Where do you think the address will point? So the 52 there is pointing to where height starts. Okay. So basically, the heap grows downwards, and the topmost byte of the chunk that got allocated for that object is its address. Okay? It's not as if this whole area got copied in here. That's for the, in some languages, if you use C and you assign a variable in C to assign to a variable in C a struct value, which you might have used in C, then what happens is that this whole block gets copied right there. That's not the case. Okay? The address of the topmost byte, okay, or word, basically the topmost slot there is, and it's going to be assigned to that variable. And so we're going to see now that the BMI spreadsheet has the address 52. Okay? Not the value 00, but just the address 52. Okay, that's very important. So, sometimes people say, oh, Java has no pointers, but C has pointers. Has anybody heard that? Has anybody ever told you in previous classes that Java has no pointers? I've had grad students tell me, but Java has no pointers. And it's very confusing what pointer means. But here, this is a pointer to that. Now, you couldn't ever find the address of something. You never see the value 52 in your program. You can never go and figure out what the address is. Whereas in C, you can do that. So to that extent, Java doesn't have pointers. But Java does have pointers because you are now writing down the address here. So when you're going to say BMI spreadsheet dot height in a program, it's going to first go and say, let me go from this variable to this object and then find height. So it's kind of indirection. You can't just immediately see the value. You have to go follow the pointer and then get it. Okay? Now, when I go and execute the statement, okay, now I got another BMI spreadsheet. Its height and weight are also 00. And now it's allocated a different area whose start address is 64. So when I go and execute that statement completely, I get BMI spreadsheet to the address 64. Okay? Last time when I showed you this thing, I kind of glossed over the pointer part. Okay, I just went and said BMI spreadsheet here. Somehow it points there, but might as well show you what's going on under the hood, because you really need to know this at some point in the course. Okay, so earlier the better. So what's going to happen now when I say BMI spreadsheet 1.setHeight 1.77?
Looks at the address and then goes to the address and sets the height where it starts.
Okay, so that's what we want, right? We want somehow 1.77 to come where in memory? Right here? That's what going to happen. Okay? But for that to happen, does something have to happen in the stack? Does some new entry have to be created in the stack? Set height method, yeah. What about it? It has a parameter, right, called new height. That somehow has to get allocated. So this set height, is just one statement here, but if you do F5 in Eclipse and go into it, you'll see that it'll first create a new height variable. The 1.77 will get assigned there. This is at the beginning of the set height call, when nothing has happened. The formal parameter is assigned the actual parameter values. Okay? And then this value now goes into set height. Okay? And when we finish set height, what will happen in memory? When we finish set height and come to BMI spreadsheet 2 is assigned BMI spreadsheet 1, at that point, what will memory look like? New height will go away. Okay? Just pop from the stack. And that's what we see. That's why here's where again we see the difference between stateful and stateless objects. Okay? Stateless objects, methods get called, memory gets allocated from stack, and the methods return, and nothing is remembered. Unless you have some state here, and which is what's happening here. That we went and captured what was sent out in this memory. And now this is there as long as the object is there. And when will the object disappear? We talked about that a little bit in the previous class. Go ahead. Garbage disposal. Garbage collection is the technical term, but garbage disposal is a fine term to use for it also. So when is garbage going to be created? So in this example, do you see garbage being created? Where is it?
When BMI spreadsheet 2 is given the same address as BMI spreadsheet 1.
So I just took BMI spreadsheet 1, assigned that to BMI spreadsheet 2, and what happens? They both point to 52. Everybody likes the BMI spreadsheet 1. At this point, there is no link to BMI spreadsheet 1, the original one. There's no way to get to it from your program. Okay? And this is not at the point at which, so firstly, the equals, sorry, this should have been assigned equals. It does an address or pointer copy. It doesn't just copy the whole object. Again, I've had grad students who often wondered about that. And because from C, that's what you're used to, you just get a pointer assignment. You just take this value and copy it. You copy its value. Okay? Its value happens to be an address. This is what happens when you assign a formal to a formal parameter and actual parameter. The value, whatever is at the slot of the actual parameter, gets copied into the formal parameter. Okay, so now there's no way to reference BMI spreadsheet 2. And at some point later, when the garbage collector runs, okay, we don't want to go and collect garbage again and again and again. It takes time. You're running your program, and your program doesn't do garbage collection. It's some other program that does garbage collection. So why should we go and run that? Switching from one program to the other is a heavyweight operation. It takes time. So you just do it when you need space sometimes. Okay? You know that from real life, right? You may either do garbage collection every spring, or you might do it every day. Okay, and maybe the happy medium is somewhere in between. And that's the kind of happy medium people tend to go towards. Okay? And at some point later, when the garbage collector runs, okay, we don't want to go and collect garbage again and again and again. It takes time. You're running your program, and your program doesn't do garbage collection. It's some other program that does garbage collection. So why should we go and run that? Switching from one program to the other is a heavyweight operation. It takes time. So you just do it when you need space sometimes. Okay? You know that from real life, right? You may either do garbage collection every spring, or you might do it every day. Okay, and maybe the happy medium is somewhere in between. And that's the kind of happy medium people tend to go towards. Okay. So, you know, I asked you last time, what's the difference between primitive value and primitive variable and object variable and object value? And you said, well, object value is typed by a type whose name begins with an uppercase. Okay? And that's sort of a nice conventional thing to do, but now you see that primitive values are not pointers, they're actual values. They fit in memory directly. Whereas primitive objects, they have addresses, and these addresses are the ones that get assigned to object variables, not the values themselves. So when you assign an object to a variable, it's not that we copy the whole slot into the variable, but you actually, all variables, object variables, have the same amount of memory allocated, one slot for one address. It's not as if different variables are different sizes. And we'll get into that a little more later when we look at wrapper types. Okay? But that's what's going on. Okay, any questions on this? Okay. So if I go and use object editor here, this is what I get. Does that make sense? I put in number 5, and then I get for square 25 and cube I get 0. How could that happen? Yeah. So what's your name? Colin?
It calculates cube with computation of value for square, and then when it goes back to calculate get square, it fills in the value for square. If you were to run it again, in fact, the value for cube would have the last value for square, the step behind when you're
Okay. So, very good. We don't know in what order the get methods get called by object editor. And your program should not depend on that at all. If your program depends on which order the get methods get called, then one of your get methods must have a side effect, one or more. Because depending on which one gets called first, the other one will return a different value. Okay? So what must have happened here is that get cube got called first. Well, that could happen because cube happens to be alphabetically before square. Okay? So if object editor is going to use some order, maybe it will use alphabetical order. Okay? And it saw the value of square as 0. It says 0 multiplied by number, which is still 0, so it went and gave you 0. And then now if I was to change 5 to 10, then as Colin said, you're going to be one step behind. So after calling get set number, object editor calls get cube before calling get square to do automatic refresh. This is what happens when you do automatic refresh. You can also do refresh explicitly. Okay, if you do explicitly refresh, it just calls all the getter methods again. Now nothing has changed, no set method has been called. So if you call the get methods again, it's going to return you the right value. So it's not a step behind because I did an explicit refresh. Okay, so this shows you why side effects are bad. How impure? So now what's your name? Jaslyn? Justin. How do you spell that? J-A? Justin. Okay. I hope that. So if a function calls another function, now in mathematics, did you ever do that? Tangent of an angle is? That's a function. Bona fide mathematical function. You took your parameters, you gave it to another function, you said you do this part, you took your parameters, gave it another function, you said do your parts. Those two functions did what returned values based purely on their parameters, which were based purely on your parameters. Your function. Do a lot of that stuff. I mean recursion. That is the function calling itself. Still, there's no global state. You take your parameter, you decrement it by 1, divide it by 2, whatever, pass it to yourself again. That's fine. So that's beautiful programming, actually. The more you decompose your problem, the better it is. And that's what people who study functional languages end up doing. They're just composing functions. That's not impure. Okay. Questions? Copy. Okay, right? So if I was to do something like this, I could do something like this. I could go, before I told object editor to edit the object, I could instantiate the object and then go and say set height to 1.77, set weight to 75.0. In this way I can always initialize the variables to something arbitrary. I could have set the height and weight to my height and weight. Yeah, but that, 0 is a good value. We don't know what else to choose. So these values should really be initialized by the one who's instantiating the object, not by the guy who defined the class. The guy who defined the class doesn't know what good values for height. Okay. So the guy who's instantiated the class can go and instantiate the class first and then call a bunch of set methods to go and make sure that the values are set before any get is called. The get will be called by object editor. So before any get is called, you just go and set it. That's something you could do. Okay? And instead of doing this, what's a cleaner way? Define a Okay, just to make this point clear, I've changed the variable name from height to HGHT. Okay, and I have changed the getters and setters also. Rather than height, get how tall, set how tall. What are my properties here? Yeah. How tall and weight and BMI. Okay, this just drives the point home that properties are a function only of the methods. They are not a function of the variables. Properties are something that external classes need to access. External classes cannot look at your variables, so properties cannot have anything to do with variables. Now I'm saying this again and again because often I get answers when I ask questions in exams. Define a property, people often say it's variable. And 90% of the time, a property will correspond to a variable. So you understand what's going on here. But it doesn't have to, and that's what I meant when, that's what you see in get BMI. And here you see that the name of the property is different from the name of the variable. Now I'm not suggesting you code this way. It's good to have the property name and the variable name the same so that you know that this method is modifying or changing this variable. But this is just to show you that is really okay, just to make this point clear, I've changed the variable name from height to HGHT. Okay, and I have changed the getters and setters also. Rather than height, get how tall, set how tall. What are my properties here? Yeah. How tall and weight and BMI. Okay, this just drives the point home that properties are a function only of the methods. They are not a function of the variables. Properties are something that external classes need to access. External classes cannot look at your variables, so properties cannot have anything to do with variables. Now I'm saying this again and again because often I get answers when I ask questions in exams. Define a property, people often say it's variable. And 90% of the time, a property will correspond to a variable. So you understand what's going on here. But it doesn't have to, and that's what I meant when, that's what you see in get BMI. And here you see that the name of the property is different from the name of the variable. Now I'm not suggesting you code this way. It's good to have the property name and the variable name the same so that you know that this method is modifying or changing this variable. But this is just to show you that is written. So name of variables don't matter. Okay, so the properties here are height, weight, and BMI. Okay, and BMI. And BMI is not a variable. I want to say that again and again. The exported state can correspond to the internal state, but doesn't have to. Height and weight are variables that are returned directly. BMI is some computed value. It's not stored in some variable. Okay? Questions?